Hello there. Tonight, we're going to explore 100 mysteries that even NASA can't explain. 100% strange phenomena, bizarre discoveries, and cosmic puzzles that have stumped the brightest minds in science. These aren't fairy tales or science fiction. These are real observations, real data, real mysteries that exist right now in our universe. And before we drift off together exploring these cosmic enigmas, if you enjoy falling asleep to the mysteries of space, consider subscribing to this channel. We explore the universe's deepest secrets every week, all designed to help you relax and drift peacefully into sleep. Let's begin with something that might be happening right above your head at this very moment. Mystery number 1. Earth's magnetic field is acting very strangely. There's a region over the South Atlantic Ocean where something weird is going on. NASA calls it the South Atlantic anomaly, and it's growing. Our planet is surrounded by a magnetic field that protects us from harmful radiation from space. It's like an invisible shield, keeping us safe. But over the South Atlantic, this shield is weakening. It's getting thinner. Satellites passing through this region experience glitches. Their computers malfunction. Sometimes they shut down completely. Astronauts aboard the International Space Station receive higher doses of radiation when they pass over this area. Scientists have been watching this anomaly for decades, and it's not getting better. It's getting worse. The weakened area is expanding, and now it's starting to split into 2 separate weak zones. Nobody knows why this is happening. Some scientists think it might be a sign that Earth's magnetic poles are about to flip, something that happens every few 100,000 years. But we're not sure. We're watching our planet protective shield develop a growing hole, and we don't fully understand what's causing it or what it means for our future. Mystery number 2 takes us away from Earth and into the depths of space. There's something pulling our entire galaxy in a direction it shouldn't be moving. Astronomers call it the Great Attractor. Imagine you're floating in a swimming pool, and suddenly you feel yourself being pulled toward one end of the pool, even though you can see nothing there pulling you. That's what's happening to our Milky Way galaxy. We're being pulled, along with thousands of other galaxies, toward a region of space about 200 million light-years away. The strange thing is, we can't see what's pulling us. It's hidden behind the disk of our own galaxy, obscured by dust and stars. Whatever it is, it's massive. It has to be, to pull entire galaxies toward it. Scientists have tried to map this region, to figure out what's there. They've found a huge concentration of mass, a supercluster of galaxies. But even that doesn't fully explain the motion we're seeing. There might be something even bigger, even more massive, lurking beyond what we can observe. We're falling towards something enormous in the cosmos, and we can't quite see what it is. Mystery number 3 is about sound, or rather the lack of it. Space is supposed to be silent. There's no air, no medium for sound waves to travel through. And yet, NASA has recorded sounds from space, strange, eerie sounds. In 2003, NASA released audio of a black hole singing. The black hole is at the center of the Perseus galaxy cluster, and it's creating sound waves in the gas surrounding it. These sound waves are incredibly deep, far below what human ears can detect. NASA had to raise the pitch by 57 octaves, that's millions and millions of times higher, to make them audible to us. When they did, we heard a deep, haunting tone, like the universe humming to itself. But here's the mystery. Black holes aren't supposed to make sound. They're regions where gravity is so strong that nothing, not even light, can escape. So how is this black hole creating sound waves? And it's not just one black hole. Scientists have found similar phenomena around other black holes and neutron stars. The universe is filled with sounds we're only beginning to hear, sounds that shouldn't exist according to our understanding of physics. Space, it turns out, is not as silent as we thought. Mystery number 4 involves something called dark flow. Imagine all the galaxies in the universe moving in random directions, spreading out as the universe expands. That's what we expect to see based on the Big Bang theory. But in 2008, scientists discovered something strange. A large group of galaxy clusters is moving in the same direction, all flowing together toward one region of space beyond the observable universe. This motion is different from the expansion of the universe. It's like a current in the ocean, pulling everything in its flow toward a distant destination. Scientists call it dark flow. The mystery is, what's causing it? What could be so massive, so powerful, that it's pulling thousands of galaxies across billions of light-years of space? Some scientists have suggested there might be another universe beyond ours, exerting gravitational influence across the boundary between universes. Others think it might be a remnant from before the Big Bang, a structure that existed in whatever came before our universe. We're watching galaxies flow towards something we can't see, pulled by forces we don't understand, toward a destination beyond the edge of everything we can observe. Mystery number 5 brings us to a cold spot in space. The universe is filled with something called the cosmic microwave background radiation. This is the leftover heat from the Big Bang, spread throughout all of space. It's incredibly uniform, with tiny variations in temperature from place to place. These tiny variations tell us a lot about the early universe. But in 2004, astronomers found a spot that's much colder than it should be. It's a vast region of space, about 1 billion light-years across, where the temperature of this background radiation is significantly lower than the surrounding area. Scientists call it the cold spot, and it shouldn't exist. According to our models of the Big Bang and the expansion of the universe, variations this large shouldn't occur. The cold spot is like finding a patch of ice in the middle of a warm ocean. Some scientists think it might be a supervoid, an enormous region of space with very few galaxies in it. Others have suggested more exotic explanations, like a collision between our universe and another universe, or a topological defect in the fabric of spacetime itself. We found a cold scar on the face of the cosmos, and we're not sure what made it. Mystery number 6 involves rogue black holes wandering through space. Most black holes we know about are sitting at the centers of galaxies, or the orbiting companion stars. But scientists have realized that there might be millions of black holes drifting through the galaxy, invisible, undetected, traveling through space with no star to give away their position. These rogue black holes formed from massive stars that exploded as supernovas. When a star goes supernova, the explosion isn't always symmetrical. Sometimes it gives the newly formed black hole a kick, sending it flying through space at incredible speeds. These black holes are out there, invisible, detectable only by the gravitational effects they have on nearby objects. We might have rogue black holes passing relatively close to our solar system, and we'd never know unless they happened to pass in front of a background star or disturb the orbit of something we're watching. There could be a black hole flying through our region of the galaxy right now, and we wouldn't see it coming. We're surrounded by invisible monsters, wandering the cosmic ocean, and we have no way to track them all. Mystery number 7 is about fast radio bursts. These are incredibly powerful pulses of radio waves that last only a few milliseconds, but release as much energy as the sun puts out in an entire day. They come from distant galaxies, billions of light-years away. The first one was discovered in 2001, but it wasn't recognized as something new until years later. Since then, scientists have detected hundreds of these bursts. The mystery is, what's causing them? They're too powerful to come from planets or normal stars. Some scientists think they might come from magnetars, neutron stars with incredibly powerful magnetic fields. Others have suggested they might be signals from alien civilizations, though most scientists think natural explanations are more likely. The really strange thing is that some of these bursts repeat. There's a source that sends out a burst every 16 days, regular as clockwork. What natural phenomenon could be so precise, so regular, and so powerful? We're detecting flashes of energy from across the universe, brief cosmic screams that appear and vanish, and we still don't know what's making them. Mystery number 8 takes us to Venus, our closest planetary neighbor. Venus is wrapped in thick clouds of sulfuric acid. These clouds are so dense that we can't see the surface from space. But when scientists look at Venus in ultraviolet light, they see dark streaks and patches moving through the clouds. These dark features absorb ultraviolet light, but scientists don't know what they're made of. They were first noticed in the 1920s, and we've been watching them ever since, but we still can't explain them. Some scientists think they might be particles of sulfur in the clouds. Others have suggested they could be microorganisms, living in the clouds of Venus, floating in the atmosphere. This is a wild idea, but Venus's clouds have regions where the temperature and pressure are similar to Earth's surface. Could there be life floating in the sky of Venus? We don't know. These dark patches remain unexplained, mysterious features on a planet that's close enough for us to visit with robotic probes, yet still keeps its secrets. Mystery number 9 involves cosmic rays, particles from space that constantly bombard Earth. Most cosmic rays are protons, the nuclei of hydrogen atoms, traveling through space at nearly the speed of light. They come from supernovas, from black holes, from the sun. We understand where most of them come from. But occasionally, scientists detect cosmic rays with energies so high they shouldn't be possible. These ultra-high-energy cosmic rays hit Earth's atmosphere with the force of a baseball thrown at 100 miles per hour, except they're single atomic particles. To accelerate a particle to such enormous energies requires conditions we can barely imagine. The most powerful particle accelerators humans have built can't come close to producing particles with this much energy. Where are these cosmic rays coming from? What could possibly accelerate them to such speeds? Scientists have looked for sources, scanning the sky for likely candidates, but the mystery remains. Some of these particles seem to come from empty regions of space, from areas where there's nothing powerful enough to create them. We're being hit by particles that travel faster and carry more energy than our physics says should be possible, and we don't know where they're coming from. Mystery number 10 is about the planet Mercury. Little Mercury, the smallest planet in our solar system, closest to the Sun, shouldn't have a magnetic field. It's too small, and it rotates too slowly. Earth has a magnetic field because it has a liquid iron core that churns and moves, generating electrical currents that create the magnetic field. This requires the planet to be large enough and rotating fast enough to keep the core churning. Mercury doesn't meet these requirements. It's tiny and it rotates very slowly, taking 59 Earth days to complete one rotation. And yet, Mercury has a magnetic field. Not a strong one, only about 1% as strong as Earth's, but it's there. NASA's Messenger spacecraft measured it carefully and confirmed that Mercury definitely has a global magnetic field. Scientists have proposed various theories to explain it. Maybe Mercury's core is partially molten in a way we don't understand. Maybe there are processes inside the planet that we haven't discovered yet. Or maybe our understanding of how magnetic fields form is incomplete. A small, slow-rotating planet is generating a magnetic field when our models say it shouldn't, and we're not sure why. Mystery number 11 involves Titan, the largest moon of Saturn. Titan is an amazing place, the only moon in the solar system with a thick atmosphere. It has lakes and rivers on its surface, not made of water but of liquid methane and ethane. It rains on Titan, but the rain is liquid methane. In many ways, Titan is like a frozen version of early Earth. The mystery is, where did all Titan's atmosphere come from? Titan's atmosphere is mostly nitrogen, just like Earth's, but it's much thicker relative to the moon's size. And it shouldn't still be there. Sunlight breaks down methane in the atmosphere, a process that should have stripped away Titan's atmosphere long ago. And yet, the atmosphere is still thick, which means something must be replenishing it. There must be a source of methane on or inside Titan that's constantly adding to the atmosphere. Scientists think there might be an underground ocean of liquid water mixed with ammonia beneath Titan's icy crust, and that methane might be escaping from this ocean through cracks in the ice. Or maybe there are methane volcanoes, erupting periodically to refresh the atmosphere. We've seen evidence of these cryovolcanoes on Titan, but we're not certain. Titan has an atmosphere it shouldn't have, refreshed by processes we haven't fully identified. Mystery number 12 is about Saturn's hexagon. At Saturn's North Pole, there's a massive, perfectly hexagonal cloud pattern. It's been there for decades. The Voyager spacecraft first photographed it in the 1980s, and it's still there today, spinning around Saturn's pole. Each side of the hexagon is wider than the diameter of Earth. It's an enormous geometric shape in the clouds, and we don't fully understand how it formed. Scientists know it's a type of atmospheric wave pattern, similar to jet streams on Earth, but why it forms a hexagon instead of a circle or some other shape is still a mystery. Laboratory experiments have shown that rotating fluids can sometimes form polygonal patterns under certain conditions, but recreating Saturn's hexagon exactly has been difficult. The hexagon changes color with the seasons on Saturn, shifting from a golden hue to a blue one, and back again. It's a permanent feature of Saturn's atmosphere, a giant geometric pattern etched into the clouds of a gas giant planet, and we're still working to understand the precise physics that creates and maintains it. Mystery number 13 brings us to Jupiter and its moon Europa. Europa is covered in ice, a thick frozen crust that covers the entire moon. But beneath that ice, scientists are almost certain there's a global ocean of liquid water. This ocean might be in contact with Europa's rocky core, which means it could have the right chemistry for life. But here's the mystery. Europa's surface is crisscrossed with cracks and ridges, and some areas appear to have been flooded with water that then refroze. This suggests the ice crust is active, moving, breaking, and reforming. Some regions of Europa are smooth, with very few craters, which means they're geologically young, recently resurfaced. But how? What's driving this activity? Europa is far from the sun, far too cold for ice to melt from solar heat. The answer seems to be tidal heating. Jupiter's enormous gravity squeezes and stretches Europa as it orbits, and this flexing generates heat inside the moon, enough to keep the subsurface ocean liquid. But the details of how this works, how much heat is generated, where exactly the ocean is and how thick the ice above it is, all of these are still uncertain. We think there's an ocean under Europa's ice, an ocean that might harbor life, but we can't see it directly, and we don't fully understand the forces shaping this mysterious moon. Mystery number 14 is about Enceladus, a small icy moon of Saturn. Enceladus is only about 300 miles in diameter, tiny compared to Earth's moon. And yet, this little moon is one of the most exciting places in the solar system. In 2005, the Cassini spacecraft discovered that Enceladus has geysers at its south pole, enormous plumes of water vapor and ice particles shooting out into space. These geysers are coming from cracks in the ice called tiger stripes, and they're evidence that Enceladus has a subsurface ocean just like Europa. But Enceladus is even smaller than Europa, so the fact that it has enough internal heat to maintain a liquid ocean is surprising. Scientists think tidal heating from Saturn is responsible, just like with Europa, but Enceladus's orbit is less eccentric, which means it should experience less tidal heating. And yet, the geysers are there, powerful and active. The water from these geysers contains organic molecules, the building blocks of life, and scientists have even detected complex organic compounds. Enceladus might have the ingredients for life in its hidden ocean. But why is such a small moon so geologically active? How is it generating enough heat? These are questions we're still trying to answer. Mystery number 15 takes us to Mars. Mars is cold, dry, and dusty today, but it wasn't always like this. Billions of years ago, Mars had liquid water on its surface. We can see the evidence everywhere: ancient riverbeds, lake beds, minerals that only form in the presence of water. Mars once had a thicker atmosphere, warm enough for water to flow. But then something happened. Mars lost its atmosphere. The solar wind, a stream of charged particles from the sun, stripped away most of Mars's air, and without the air, the water evaporated or froze. The mystery is, what exactly happened? Why did Mars lose its atmosphere while Earth kept its? One key difference is that Mars doesn't have a strong magnetic field like Earth does. Earth's magnetic field deflects the solar wind, protecting our atmosphere. Mars might have had a magnetic field early in its history, but it shut down, leaving the planet vulnerable. Why did Mars's magnetic field disappear? It might be related to the planet's size. Mars is smaller than Earth, so its interior cooled faster, and when the core cooled, it stopped generating a magnetic field. But the details are unclear. We're looking at a planet that was once warm and wet, possibly even habitable, and we're trying to understand the sequence of events that turned it into the frozen desert it is today. Mystery number 16 involves methane on Mars. Despite being a cold, dry planet, Mars has methane in its atmosphere. Not a lot, just trace amounts, but it's there, and it varies with the seasons. Methane is significant because on Earth, most methane is produced by living organisms. It's a byproduct of biological processes. There are also geological sources of methane, like volcanic activity, but Mars doesn't have active volcanoes as far as we know. So where is the methane coming from? Scientists have proposed several possibilities. It could be coming from underground reservoirs, ancient methane trapped in the rocks that's slowly leaking out. It could be produced by chemical reactions between rocks and water in the Martian subsurface, or, and this is the exciting possibility, it could be produced by microbes living beneath the surface of Mars. We don't know. The methane appears and disappears in ways we don't fully understand. Concentrations spike in certain seasons and in certain locations, then drop again. NASA's Curiosity rover has measured these variations, but we still don't have a definitive explanation. There's methane on Mars, and we don't know why. Mystery number 17 is about the asteroid Oumuamua. In 2017, astronomers detected an object passing through our solar system. It was moving fast, too fast to be orbiting the Sun, which meant it came from interstellar space. This was the first interstellar object ever detected. Astronomers named it Oumuamua, a Hawaiian word meaning scout or messenger. As they studied it, they realized it was very strange. Its shape was odd, elongated like a cigar or a pancake, unlike any asteroid or comet we'd seen before. And then it did something unexpected. As Oumuamua passed the Sun and started moving back out toward interstellar space, it accelerated slightly, faster than it should have if gravity alone were acting on it. Comets do this when ice on their surface evaporates and the escaping gas gives them a little push. But Oumuamua didn't show any signs of having a tail or releasing gas like a comet. So what pushed it? Some scientists suggested it might have a coating of frozen hydrogen that evaporated without being visible. Others proposed it might be a piece of a planet, torn apart by tidal forces. And a few, including a Harvard astronomer, suggested it might be an alien spacecraft, a light sail pushed by radiation pressure. Most scientists think natural explanations are more likely, but we don't have a definitive answer. Oumuamua is now far beyond our ability to study, heading back into deep space, and we'll probably never know for sure what it was. Mystery number 18 involves the rings of Saturn. Saturn's rings are beautiful, vast, and incredibly thin. They stretch out hundreds of thousands of miles from the planet, but are only about 30 feet thick in most places. They're made of countless chunks of ice, ranging from tiny grains to house-sized boulders, all orbiting Saturn. The mystery is, how old are the rings? For a long time, scientists thought they were ancient, formed at the same time as Saturn billions of years ago. But recent data from NASA's Cassini spacecraft suggests the rings might be much younger, perhaps only a few 100 million years old. The rings are too bright and clean to be ancient. Over billions of years, they should have been darkened by dust from comets and micrometeorites. The fact that they're still so bright suggests they're young. But if they're young, where did they come from? Did a moon get too close to Saturn and get torn apart by tidal forces? Did an icy object from the outer solar system wander into Saturn's gravitational field and get shredded? We don't know. Saturn's rings might be a recent temporary feature of the solar system, and we're lucky to be alive at a time when they exist. but how they formed is still a mystery. Mystery number 19 is about Pluto's heart. When NASA's New Horizons spacecraft flew by Pluto in 2015, it revealed a world far more complex and geologically active than anyone expected. One of the most striking features is a bright, heart-shaped region called Tombaugh Regio. The left side of the heart is a smooth plain of nitrogen ice called Sputnik Planitia. This plain appears to be constantly renewing itself, with fresh ice rising from below and old ice sinking, like a lava lamp. The mystery is, what's driving this activity? Pluto is a tiny, frozen world far from the sun. It shouldn't have the internal heat to drive geological activity, and yet Sputnik Planitia is active, with convection currents churning the ice. Scientists think the ice itself might be providing the energy. Nitrogen ice is just barely solid at Pluto's temperature, and small amounts of heat from radioactive decay in Pluto's interior might be enough to keep it convecting. But there are other mysteries too. The heart-shaped region is aligned with Pluto's largest moon, Charon, always facing the same direction. This might not be a coincidence. The mass of the ice in Sputnik Planitia might have caused Pluto to reorient itself so that the heavy region points toward Charon. It's a fascinating interplay of geology and orbital dynamics, and scientists are still working out the details. Mystery number 20 brings us to the Kuiper Belt, the region beyond Neptune filled with icy bodies left over from the formation of the solar system. In 2016, astronomers announced evidence for a possible ninth planet in the outer solar system, a planet much larger than Pluto, orbiting far beyond Neptune. They call it Planet 9, though it hasn't been directly observed yet. The evidence comes from the orbits of distant Kuiper Belt objects. Several of them have orbits that are tilted and elongated in similar ways, as if they're being influenced by the gravity of something large. Computer simulations suggest that a planet with about 5 to 10 times the mass of Earth, orbiting hundreds of times farther from the Sun than Earth does, could explain these patterns. But where is this planet? Why haven't we seen it? The problem is, it's very far away and very faint. It would be difficult to spot even with our best telescopes. Astronomers are searching, scanning the sky, looking for a faint moving object that might be Planet 9. Some scientists are skeptical and think the evidence could be explained in other ways. But if Planet 9 is real, it would be one of the most significant discoveries in astronomy in decades. There might be another planet in our solar system, a hidden world we've never seen, and we're hunting for it right now. Mystery number 21 is about Neptune's moon Triton. Triton is the 7th largest moon in the solar system, and it's one of the coldest objects we've ever measured, with surface temperatures around minus 390 degrees Fahrenheit. But despite being so cold, Triton is geologically active. When Voyager 2 flew by in 1989, it discovered geysers on Triton's surface, plumes of nitrogen gas and dark particles shooting up to 5 miles high. These geysers are thought to be powered by sunlight, even though the sun is incredibly faint out at Neptune's distance. The idea is that sunlight penetrates the clear nitrogen ice on Triton's surface and heats the darker material below, causing the nitrogen to vaporize and erupt through weak spots in the ice. But here's the bigger mystery about Triton. It's orbiting Neptune backward. Every other large moon in the solar system orbits in the same direction as its planet rotates, but Triton goes the opposite way. This retrograde orbit tells us that Triton didn't form around Neptune. It must have been captured, probably from the Kuiper Belt. Neptune's gravity grabbed Triton as it passed by and pulled it into orbit. But capturing such a large object is incredibly difficult. The physics required for this to happen are very specific, and scientists are still working out exactly how it could have occurred. Triton is a captured world, orbiting backward, shooting geysers into space, and we're still piecing together its strange history. Mystery number 22 involves the rotation of Venus. Venus spins very slowly on its axis, taking 243 Earth days to complete one rotation. That's longer than a Venusian year, which is only 225 Earth days. So on Venus, a day is longer than a year. But even stranger, Venus rotates backward compared to most planets in the solar system. If you could stand on Venus and watch the sun rise, it would rise in the west and set in the east, the opposite of what happens on Earth. Scientists call this retrograde rotation, and it's a mystery. What caused Venus to spin this way? One theory is that Venus originally rotated normally, but a massive collision with another large object early in the solar system's history flipped it over or spun it backward. Another idea is that tidal forces from the sun gradually slowed Venus's rotation and eventually reversed it. Venus's thick atmosphere might also play a role, creating friction that affects the planet's spin, but none of these explanations is entirely satisfying. The truth is, we don't know for certain why Venus rotates the way it does. It's spinning slowly backward through space, and the reason remains unclear. Mystery number 23 takes us to a region of space called the local void. Our Milky Way galaxy is part of a cosmic structure called the local group, which includes Andromeda and about 50 smaller galaxies. The local group is part of an even larger structure called the Virgo supercluster. These structures are separated by enormous empty regions called voids. Just beyond the Milky Way, there's a particularly large void called the local void. It's about 150 million light-years across, and it contains very few galaxies. Voids are normal in the large-scale structure of the universe, regions where dark matter and normal matter are less dense, so galaxies don't form as frequently. But the local void is peculiar because of its effect on our motion through space. The lack of mass in the void means there's less gravitational pull from that direction, which contributes to our galaxy's motion toward denser regions. Scientists have been mapping the local void to understand its structure better, and they've found it's not completely empty. There are few small galaxies drifting through it. But the mystery is understanding exactly how these voids form and evolve. Computer simulations of the universe's large-scale structure can create voids, but matching the observations precisely is challenging. We live on the edge of a vast cosmic emptiness, and we're still learning how these empty regions fit into the structure of the universe. Mystery number 24 is about water on the moon. For a long time, scientists thought the moon was completely dry. It's airless, exposed to the vacuum of space, and any water on the surface should evaporate or be broken apart by solar radiation. But in recent years, spacecraft have detected signs of water on the moon, not just in permanently shadowed craters at the poles where ice could survive, but also in sunlit areas. In 2020, NASA announced that its SOFIA telescope had detected water molecules on the moon's sunlit surface. The amounts are tiny, about as much water as a small bottle distributed across a cubic meter of soil, but it's there. The mystery is, how is this water surviving? Where is it coming from? One possibility is that it's being created by solar wind. The solar wind contains hydrogen, and when hydrogen atoms hit oxygen in the lunar soil, they can combine to form water. Another idea is that the water is hiding in small shadows, tiny pockets of shade created by rocks and crater rims, where ice can survive even in sunlit regions. Or maybe water is being delivered constantly by micrometeorites that contain ice. We've found water on a world we thought was bone dry, and we don't fully understand how it got there or how it's persisting. Mystery number 25 involves the moons of Mars. Mars has two small moons, Phobos and Deimos. They're tiny, irregularly shaped, and they look a lot like asteroids. For a long time, scientists assumed they were asteroids that Mars captured from the nearby asteroid belt. But there's a problem with this idea. Captured moons usually have tilted, elliptical orbits, but Phobos and Deimos orbit almost perfectly in Mars's equatorial plane, in nearly circular orbits. This suggests they formed around Mars rather than being captured. But how could they form there? One theory is that a giant impact on Mars early in its history threw debris into orbit, and this debris coalesced to form Phobos and Deimos, similar to how Earth's moon is thought to have formed. But the chemistry of the moons doesn't quite match what we'd expect from Martian material. Recent studies suggest Phobos and Deimos might be a mix of captured asteroid material and debris from a Mars impact. It's a hybrid origin story, and scientists are still working out the details. To make things even more interesting, Phobos is slowly spiraling inward toward Mars. In about 50 million years, it will either crash into the planet or be torn apart by tidal forces, forming a ring around Mars. We're watching a moon in its final orbits, heading toward destruction, and we're still not entirely sure where it came from. Mystery number 26 is about the Great Red Spot on Jupiter. The Great Red Spot is a gigantic storm, a hurricane that's been raging in Jupiter's atmosphere for at least 300 years, possibly much longer. It's enormous, large enough to swallow 2 or 3 Earths, but it's shrinking. Observations over the past century show that the Great Red Spot is getting smaller. In the 1800s, it was about twice as wide as it is now. Scientists don't know why it's shrinking or if it will eventually disappear. They also don't know exactly what gives the Great Red Spot its red color. The storm is mostly hydrogen and helium, like the rest of Jupiter's atmosphere, but something in the clouds is creating that distinctive red hue. It might be complex organic molecules formed by lightning or ultraviolet light, or it might be compounds brought up from deeper in the atmosphere. And here's another mystery. How has the Great Red Spot lasted so long? Storms on Earth last days or weeks. Even the longest-lived hurricanes don't last more than a few weeks. But the Great Red Spot has persisted for centuries. What keeps it going? Scientists think it's sustained by Jupiter's internal heat and the planet's rapid rotation, which creates strong jet streams that contain the storm and prevent it from dissipating. But the exact mechanisms are still being studied. We're watching a storm larger than our planet, centuries old, slowly shrinking, and we don't fully understand what powers it or what will happen to it. Mystery number 27 takes us to Uranus. Uranus is a strange planet in many ways. It rotates on its side, with its axis tilted 98 degrees. This means Uranus essentially rolls around the Sun like a ball, with each pole experiencing 42 years of continuous sunlight, followed by 42 years of darkness. The leading theory for this extreme tilt is that Uranus was knocked over by a massive collision early in the solar system's history, either with another planet-sized object or perhaps multiple smaller impacts. But there are problems with this idea. If Uranus was hit hard enough to tip it over, its moons should have been scattered or lost. Instead, the moons orbit around Uranus's equator, perfectly aligned with its tilted axis, as if they formed after the planet was already tilted. This has led some scientists to suggest that maybe Uranus wasn't tipped over by a single giant impact. Maybe it was tilted gradually by gravitational interactions with other planets. Or maybe the tilting happened while the planet was still forming and gathering its moons. The mystery deepens when we consider Uranus's magnetic field. The magnetic field is tilted 60 degrees from the planet's rotation axis and offset from the center of the planet. This is very unusual. On Earth and most other planets, the magnetic field aligns roughly with the rotation axis. On Uranus, it's wildly tilted and off-center. Scientists aren't sure why. It might have to do with the structure of Uranus's interior, where the magnetic field is generated in a slushy layer of water, ammonia, and methane, rather than in a core. Uranus is a planet that rolls on its side with a misaligned magnetic field, and we're still trying to understand what made it this way. Mystery number 2008 is about Iapetus, one of Saturn's moons. Iapetus is sometimes called the yin-yang moon because one hemisphere is very bright, covered in ice, while the other hemisphere is very dark, almost black. The contrast is striking. When Voyager and later Cassini photographed Iapetus, they revealed this dramatic two-toned appearance. Scientists think the dark material might be dust from Phoebe, another of Saturn's moons, that has fallen onto Iapetus over millions of years. The dark material absorbs more sunlight, which causes the ice beneath it to sublimate, exposing more dark material, which absorbs more heat, creating a runaway effect. But this doesn't fully explain the pattern. The dark region is almost perfectly aligned with the direction Iapetus travels in its orbit, as if it's sweeping up material like a car windshield collecting bugs. But there's more. Iapetus has a massive ridge running along its equator, a ridge that's over 12 miles high in places and stretches more than 800 miles. This ridge makes Iapetus look like a walnut. How did this ridge form? No other moon in the solar system has anything like it. Some scientists think it might be the remains of a ring system that collapsed onto the moon's surface early in its history. Others suggest it could be the result of Iapetus spinning much faster in the past and then slowing down, causing the equatorial bulge to freeze in place. We're looking at a moon with two faces and a mysterious mountain range circling its equator, and we don't have definitive answers for either feature. Mystery number 29 involves cosmic voids and supervoids. We've talked about the local void, but there are even larger voids in the universe. The largest known void is called the Boots void, discovered in 1981. It's about 330 million light-years in diameter, and it contains very few galaxies, maybe only 60 galaxies, in a space where we'd expect to find thousands. Even more puzzling is the fact that some voids seem to have an effect on the cosmic microwave background radiation. Remember the cold spot we discussed earlier? Some scientists think it might be caused by a supervoid, an enormous empty region of space that the microwave background radiation passes through on its way to us. The supervoid would cause a slight cooling effect due to a phenomenon called the integrated Sachs-Wolf effect. But when scientists looked for a supervoid in the direction of the cold spot, they found one. But it doesn't seem large enough to fully explain the temperature drop, so maybe there's something else going on. Voids are a natural part of the universe's structure, created by the way dark matter and normal matter clump together after the Big Bang. But the details of how voids grow and how they affect light passing through them are still being worked out. We're mapping enormous empty regions of space and discovering that even emptiness has mysteries. Mystery number 30 is about the sun's corona. The corona is the sun's outer atmosphere, a region of extremely hot gas that extends millions of miles into space. You can see it during a total solar eclipse as a white halo around the darkened disk of the sun. The mystery is, why is the corona so hot? The surface of the sun is about 10,000 degrees Fahrenheit. As you move away from the surface, you'd expect the temperature to drop, just like moving away from a fire makes you cooler. But the corona is much hotter than the surface, reaching temperatures of several million degrees. This violates our normal understanding of heat flow. Heat doesn't spontaneously flow from a cooler region to a hotter one. So what's heating the corona? Scientists have proposed several mechanisms. Magnetic fields in the sun's atmosphere might twist and snap, releasing energy that heats the corona. Sound waves generated by convection inside the sun might carry energy up into the corona. Tiny explosions called nanoflares might be constantly heating the gas. NASA's Parker Solar Probe is flying closer to the sun than any spacecraft before, diving through the corona to measure its temperature, magnetic fields, and plasma directly. The mission is providing new data, but the corona heating problem isn't fully solved yet. The sun's outer atmosphere is millions of degrees hotter than its surface, and we're still figuring out exactly why. Mystery number 31 takes us to neutron stars. Neutron stars are the collapsed cores of massive stars that exploded as supernovas. They're incredibly dense, packing more mass than the sun into a sphere only about 12 miles across. A teaspoon of neutron star material would weigh about 1 billion tons on Earth. Neutron stars have the strongest magnetic fields in the universe, and they spin incredibly fast, sometimes hundreds of times per second. Some neutron stars, called magnetars, have magnetic fields thousands of times stronger than typical neutron stars. These magnetic fields are so powerful they can distort the shape of atoms. The mystery is, what's inside a neutron star? We know the outer layer is made of neutrons packed together so tightly they're almost touching. But as you go deeper, the pressure and density increase to levels we can't recreate in laboratories. Theoretical physics suggests that under these extreme conditions, matter might exist in exotic states. Neutrons might break down into their constituent quarks, creating a quark soup. There might be strange matter, a hypothetical state where strange quarks are present along with the normal up and down quarks. Some theories even suggest neutron star cores might contain superfluid neutrons or superconducting protons. We can observe neutron stars from a distance, measure their mass and spin, but we can't see inside them. The conditions at their cores are beyond anything we can test, and we're left with theories and speculation about what matter becomes under such unimaginable pressure. Mystery number 32 is about pulsars. Pulsars are neutron stars that emit beams of radiation from their magnetic poles. As the neutron star spins, these beams sweep across space like a lighthouse beam, and if one of the beams points toward Earth, we see a pulse of radiation each time the star rotates. Some pulsars are incredibly precise, ticking like cosmic clocks with accuracy that rivals atomic clocks. But here's the mystery. Some pulsars occasionally glitch. They suddenly spin a tiny bit faster, then gradually slow back down to their normal rate. These glitches are rare and unpredictable. Scientists think they're caused by sudden rearrangements of material inside the neutron star. The outer crust of the star is solid, but the interior might contain superfluid, a frictionless fluid that can flow without resistance. If the superfluid spins slightly faster than the crust, and then suddenly transfers some of its angular momentum to the crust, the star would speed up. This is the leading theory, but the details are uncertain. We can't see inside neutron stars, so we're inferring what's happening from these sudden changes in spin rate. Pulsars are giving us clues about exotic states of matter, but interpreting those clues is challenging. Mystery number 33 involves the mysterious dimming of Betelgeuse. Betelgeuse is a red supergiant star in the constellation Orion, one of the brightest stars in the night sky. It's nearing the end of its life and will eventually explode as a supernova, though that could happen tomorrow or 100,000 years from now. In late 2019 and early 2020, Betelgeuse dimmed dramatically, dropping to about 40% of its normal brightness. Astronomers around the world watched closely, wondering if the star was about to explode. But then it brightened again, returning to near normal. What happened? Scientists now think Betelgeuse ejected a large cloud of dust that temporarily blocked some of its light from our view. The star's surface is turbulent, with giant convection cells moving hot gas up and down. One of these convection events might have thrown off a huge mass of material that cooled and condensed into dust, creating a temporary veil. But this is still somewhat speculative. The dimming event reminded us how little we understand about the final stages of massive stars. Betelgeuse will explode someday, and when it does, it will be bright enough to see during the daytime and will remain visible for weeks. But predicting exactly when is impossible. The star is variable, constantly changing, and we're watching it evolve in real time, waiting for the eventual spectacular end. Mystery number 34 is about hypervelocity stars. These are stars moving so fast they're escaping the galaxy entirely. Typical stars orbit the galactic center at a few hundred kilometers per second, but hypervelocity stars are traveling at over 1,000 kilometers per second, fast enough to break free from the Milky Way's gravity. The first hypervelocity star was discovered in 2005, and since then, astronomers have found dozens more. The mystery is, what accelerated them to such high speeds? The leading theory is that these stars were once part of binary star systems that wandered too close to the supermassive black hole at the center of the galaxy. The black hole's gravity captured one star and flung the other away at tremendous speed, like a gravitational slingshot. But not all hypervelocity stars seem to come from the galactic center. Some appear to have been ejected from other regions of the galaxy, possibly by supernova explosions or interactions with clusters of stars. We're finding stars that are being thrown out of the galaxy, and each one has a story about a violent event in its past, an event we're trying to reconstruct from the star's motion and trajectory. Mystery number 35 takes us to the surface of Mars again, specifically to recurring slope lineae. These are dark streaks that appear on Martian slopes during warm seasons and fade during cold seasons. They were discovered by the Mars Reconnaissance Orbiter in 2010. The streaks appear to flow downhill, darkening the surface as they go, then fading when temperatures drop. When they were first discovered, scientists thought they might be caused by liquid water seeping out of the ground and flowing downhill. Liquid water on Mars would be incredibly exciting because it could potentially support microbial life. But there's a problem. The temperatures and atmospheric pressure on Mars are so low that liquid water shouldn't be stable on the surface. It would either freeze or evaporate almost immediately. More recent studies suggest the streaks might be caused by flowing sand or dust, driven by sublimating carbon dioxide ice or some other dry process. But the debate isn't settled. Some scientists still think briny water mixed with salts that lower its freezing point, might be involved. The mystery is what exactly these streaks are. They appear and disappear with the seasons, they flow downhill, and they happen in specific locations on Mars. We're watching something dynamic happen on the Martian surface, and we're not entirely sure what it is. Mystery number 36 involves Ceres, the largest object in the asteroid belt between Mars and Jupiter. Ceres is big enough that its gravity has pulled it into a round shape, making it a dwarf planet like Pluto. When NASA's Dawn spacecraft arrived at Ceres in 2015, it found a world covered in craters, as expected, but also some very bright spots. The brightest spot is in a crater called a crater. These bright areas turned out to be deposits of salt, sodium carbonate left behind when briny water from Ceres' interior seeped up through cracks and evaporated. This tells us that Ceres has or had liquid water beneath its surface. The spacecraft also detected a thin temporary atmosphere of water vapor around the bright spots, suggesting that water might still be escaping from the interior. The mystery is, does Ceres still have a liquid ocean beneath its crust? It's possible. Ceres might have enough internal heat from radioactive decay to keep a subsurface ocean liquid. If so, it would be another candidate for potential microbial life, a hidden ocean inside a rocky world in the asteroid belt. Scientists are studying Dawn's data to figure out how deep the liquid might be, how salty it is, and whether it's still there today. Ceres went from being just a large asteroid to being a potentially ocean-bearing world, and that's a mystery we're still exploring. Mystery number 37 is about fast-moving stars near the supermassive black hole at the center of our galaxy. Scientists have been watching these stars for decades, tracking their orbits as they whip around the black hole at incredible speeds. One star, called S2, orbits the black hole every 16 years, reaching speeds of about 5,000 kilometers per second at its closest approach. By watching these stars, astronomers have confirmed that there's definitely a supermassive black hole at the galactic center, with a mass of about 4 million suns. But here's the mystery. There are even faster moving objects near the black hole, objects that appear to be clouds of gas rather than stars. One of these, called G2, was predicted to pass very close to the black hole in 2014. Scientists thought the black hole's gravity might tear the gas cloud apart and devour it, creating a bright flare. But when G2 made its closest approach, nothing dramatic happened. The cloud survived, stretched out a bit, but didn't get shredded. This has led some astronomers to think G2 might not be just a gas cloud. There might be a star hidden inside it, and the gas is just an envelope around the star. But we're not sure. There are several of these mysterious objects orbiting the black hole, and we don't fully understand what they are. They're giving us a close-up view of the extreme environment near a supermassive black hole, but they're also raising new questions. Mystery number 38 involves the rotation curves of galaxies. When astronomers measure how fast stars orbit in galaxies, they find something strange. Stars far from the galactic center are moving faster than they should be based on the visible mass of the galaxy. According to Newton's laws, stars farther from the center should orbit more slowly, just like the outer planets in our solar system orbit the Sun more slowly than the inner planets. But in galaxies, the rotation speed stays roughly constant even far from the center. This suggests there's more mass in galaxies than we can see, mass that's not emitting light. Scientists call this dark matter. It's invisible, doesn't interact with light, but it has gravity. Dark matter is thought to make up about 85% of the matter in the universe. But here's the mystery. We don't know what dark matter is. It's not made of atoms like normal matter. It doesn't emit, absorb, or reflect light. We can only detect it through its gravitational effects. Scientists have proposed many candidates for what dark matter might be. It could be exotic particles that barely interact with normal matter, particles like WIMPs, weakly interacting massive particles, or axions. Or it could be something else entirely. Despite decades of searching with sensitive detectors, we haven't directly detected dark matter particles yet. We know it's there because of its gravitational effects, but we don't know what it is. It's one of the biggest mysteries in physics. Mystery number 39 is about dark energy. In the late 1990s, astronomers made a shocking discovery. The expansion of the universe is accelerating. After the Big Bang, the universe has been expanding, with galaxies moving apart from each other. For most of cosmic history, gravity has been slowing this expansion down, like a ball thrown in the air gradually slowing as it rises. But observations of distant supernovas showed that the expansion started accelerating about 5 billion years ago. Something is pushing the universe to expand faster and faster. Scientists call this mysterious force dark energy. It makes up about 68% of the total energy content of the universe. But we have no idea what it is. It could be a property of space itself, a cosmological constant as Einstein once proposed. It could be a new kind of field permeating the universe, or it could be a sign that our understanding of gravity is incomplete. Dark energy is causing the universe to expand faster over time, and if this continues, galaxies outside our local group will eventually move so far away that their light will no longer reach us. Billions of years from now, the night sky might look very empty, with only our local galaxies visible. Dark energy is shaping the fate of the universe, and we don't understand it. Mystery number 40 takes us back to Earth, to the Aurora Borealis and Aurora Australis, the northern and southern lights. These beautiful displays of colored light in the sky are caused by particles from the sun hitting Earth's atmosphere. The solar wind carries charged particles that get funneled toward the poles by Earth's magnetic field. When these particles collide with oxygen and nitrogen in the atmosphere, they cause the gases to glow, creating the shimmering curtains of light we see. Scientists understand the basic mechanism, but there are still mysteries. Sometimes the auroras produce strange features, like pulsating patches, flickering lights, or even a phenomenon called STEVE, which stands for Strong Thermal Emission Velocity Enhancement. STEVE appears as a narrow ribbon of purple light stretching across the sky, and it's caused by a stream of hot, fast-moving gas in the upper atmosphere. STEVE was only recognized as a distinct phenomenon in 2016, even though amateur photographers had been capturing it for years. There are also proton auroras, which are invisible to the human eye but can be detected with special cameras. And recently, scientists discovered that auroras can produce sounds, faint crackling or whooshing noises, though the mechanism for this isn't fully understood. The auroras are one of the most studied phenomena in atmospheric physics, and yet they still surprise us. Mystery number 41 is about lightning on other planets. We're familiar with lightning on Earth, those dramatic bolts of electricity that flash during thunderstorms. But lightning happens on other planets too, and in some cases it's very different from what we experience. Jupiter and Saturn both have lightning storms, and the lightning there can be much more powerful than on Earth. Jupiter's lightning bolts can be thousands of times stronger than Earth's. But here's what's strange. On Jupiter and Saturn, the lightning seems to come from deep within the atmosphere, from layers where there's no water. On Earth, lightning is associated with water clouds and ice particles rubbing together to create electrical charges. But on gas giant planets, The chemistry is different. The clouds might be made of ammonia or other compounds. Scientists detected radio signals from lightning on Jupiter decades ago, but it's only recently that spacecraft like Juno have been able to study these storms in detail. The mystery deepens when we look at Uranus and Neptune. These ice giant planets should have conditions suitable for lightning, but we've only detected it rarely. Voyager detected possible lightning on Uranus, but the signals were weak and ambiguous. Why would Uranus and Neptune have less lightning than Jupiter and Saturn? It might have to do with the different compositions of their atmospheres, or the way heat moves through these planets. We're discovering that lightning is a common phenomenon throughout the solar system, but each planet does it differently, and we're still learning the details. Mystery number 42 involves methane lakes on Titan. Titan, Saturn's largest moon, is the only place besides Earth where we found stable liquids on the surface. But these aren't lakes of water. They're lakes and seas of liquid methane and ethane. The largest, called Kraken Mare, is bigger than the Caspian Sea on Earth. NASA's Cassini spacecraft mapped these lakes using radar, and it sent the Huygens probe to land on Titan's surface in 2005. The mystery is what scientists call the missing ethane problem. Based on calculations of how much methane is broken down by sunlight in Titan's atmosphere, there should be much more ethane on the surface than we see. The chemical reactions in the atmosphere should have produced enough ethane over Titan's history to cover the moon in a liquid layer hundreds of feet deep. But we don't see that much ethane. Where did it go? Some scientists think it might have soaked into the surface, absorbed by porous ice. Others suggest there might be processes converting ethane back into methane that we don't understand yet. Or maybe our estimates of Titan's age or the rate of chemical reactions are wrong. Titan's hydrocarbon cycle is like Earth's water cycle, but with methane instead of water, and we're still figuring out how all the pieces fit together. Mystery number 43 is about the Pioneer anomaly. Pioneer 10 and 11 were spacecraft launched in the early 1970s to explore the outer solar system. After completing their missions and heading out toward interstellar space, scientists noticed something odd. The spacecraft was slowing down slightly more than expected. The deceleration was tiny, only about 1/10 billionth of Earth's gravity, but it was measurable and consistent. For years, this was a genuine mystery. Was it a sign of new physics, some unknown force acting on the spacecraft, or was there a mundane explanation? Scientists considered many possibilities. Maybe gas leaking from the spacecraft was creating a tiny thrust in the opposite direction. Maybe the spacecraft's radioactive power sources were emitting more heat in one direction than another, creating a subtle push. After careful analysis of the spacecraft's thermal properties and detailed modeling of how heat radiated from different parts of the craft, scientists concluded that uneven heat radiation was likely the cause. The mystery appears to be solved, but it took decades and a lot of detective work. The Pioneer anomaly reminds us that even small, unexplained effects are worth investigating because they might reveal something important, even if the answer turns out to be less exotic than we hoped. Mystery number 44 involves the WOW signal. On August 15, 1977, a radio telescope in Ohio detected a strong narrow-band radio signal coming from the direction of the constellation Sagittarius. The signal lasted for 72 seconds, rising and falling in intensity in a pattern consistent with a signal from space that the telescope's beam was sweeping across. The astronomer monitoring the data was so surprised he wrote, "Wow," in the margin, and the signal has been called the WOW signal ever since. The signal had characteristics that made it look like it might be artificial, like a transmission from an intelligent source. It was at a frequency close to the emission line of hydrogen, which scientists have long thought would be a natural choice for interstellar communication because hydrogen is the most common element in the universe. But the signal was never detected again, despite numerous follow-up observations. Without a repeat detection, we can't confirm what it was. Was it a signal from an alien civilization? Was it interference from Earth, perhaps a satellite or airplane? Was it a natural astronomical phenomenon we don't understand? The most recent investigations have suggested it might have been caused by a comet that was in that region of the sky at the time, releasing hydrogen gas that could produce a signal at that frequency. But this explanation is controversial, and not all scientists accept it. The WOW signal remains one of the most intriguing candidate signals in the search for extraterrestrial intelligence, a tantalizing hint that remains unexplained. Mystery number 45 is about the interstellar medium, the gas and dust between the stars. Space isn't completely empty. There's a thin scattering of hydrogen atoms, about 1 atom per cubic centimeter on average, along with trace amounts of helium and heavier elements. There are also molecules, complex organic compounds that form in the cold darkness between stars. Scientists have detected hundreds of different molecules in interstellar space, including water, alcohol, formaldehyde, and even sugars and amino acids, the building blocks of life. The mystery is how these complex molecules form in such a harsh environment. Space is cold, nearly absolute zero, and there's very little material for molecules to interact with. The leading idea is that molecules form on the surfaces of tiny dust grains. Atoms stick to the dust, slide across the surface, and react with other atoms, building up more complex molecules. When stars form and heat the surrounding gas, these molecules evaporate from the dust grains and can be detected with radio telescopes. But we're still discovering new molecules and trying to understand the chemistry happening in these dark, cold clouds. The space between stars is a vast chemical laboratory, churning out the raw materials for planets and life, and we're just beginning to understand how it works. Mystery number 46 takes us to the volcanoes of Io. Io is one of Jupiter's moons, and it's the most volcanically active body in the solar system. Its surface is covered with volcanoes, constantly erupting, spewing sulfur and sulfur dioxide hundreds of miles into space. Some of Io's volcanic plumes are so large they can be seen from Earth with powerful telescopes. The heat from these volcanoes comes from tidal heating, the same process we discussed with Europa. Jupiter's gravity squeezes and stretches Io as it orbits, generating friction and heat inside the moon. But here's the mystery. Io is being heated so much that it should have lost all its internal heat long ago. The amount of energy being released by Io's volcanoes is enormous, more than can be easily explained by tidal heating alone, at least according to some models. There might be additional sources of heat, or our models of how tidal heating works might be incomplete. Another mystery is Io's lack of water. Most moons in the outer solar system are rich in water ice, but Io is dry. The intense volcanic activity might have driven off any water that was originally there, but the details are unclear. And then there's the question of Io's interior structure. We think Io has a partially molten mantle and possibly a metallic core, but we can't see inside the moon. Everything we know comes from observing the volcanoes and measuring Io's gravitational field. Io is a world turned inside out by tidal forces, and it's teaching us about the extreme conditions that can exist in the solar system. Mystery number 47 is about gamma-ray bursts. These are the most powerful explosions in the universe, brief flashes of gamma rays that can outshine entire galaxies for a few seconds. They were discovered by accident in the late 1960s by military satellites designed to detect nuclear weapons tests. The satellites saw flashes of gamma rays coming from space, and scientists eventually realized these were coming from incredibly distant galaxies, billions of light years away. For an explosion to be visible from such distances, it has to be extraordinarily powerful. Scientists now think there are two types of gamma-ray bursts. Short bursts, lasting less than 2 seconds, are probably caused by the collision of two neutron stars or a neutron star and a black hole. Long bursts, lasting more than 2 seconds, are thought to come from the collapse of massive stars into black holes, a type of supernova called a hypernova. But there are still mysteries. The exact mechanism that produces the gamma-ray beam isn't fully understood. The explosions seem to focus their energy into narrow jets, and we only see a gamma-ray burst if one of these jets happens to point toward Earth. This means there are probably many more of these explosions happening that we don't see, and there's the mystery of what happens after the burst. Some gamma-ray bursts are followed by an afterglow, a fading emission of lower energy light that can last for days or weeks. This afterglow is produced as the explosion plows through the surrounding gas, but the details of how this works are still being studied. Gamma-ray bursts are cosmic catastrophes, the deaths of stars and the births of black holes, and we're still piecing together the full story. Mystery number 48 involves cosmic strings. These are theoretical objects predicted by some models of the early universe. According to these theories, as the universe cooled after the Big Bang, it went through phase transitions similar to water freezing into ice. During these transitions, defects might have formed in the fabric of space-time, like cracks in ice. Cosmic strings would be linear defects, incredibly thin but stretching across vast distances, possibly across the entire universe. They would be unimaginably dense, with a single inch of cosmic string weighing more than the Earth. If cosmic strings exist, they would have powerful gravitational effects. They could bend light passing near them, creating double images of distant galaxies. They might generate gravitational waves as they move and oscillate. Scientists have searched for evidence of cosmic strings by looking for these telltale signs, but so far, they haven't found any definitive proof. The lack of evidence suggests that if cosmic strings exist, they're very rare, or the conditions in the early universe didn't favor their formation. But the search continues because finding a cosmic string would be an incredible discovery, confirming predictions about the fundamental nature of space-time and the conditions of the early universe. They remain theoretical, a mystery waiting to be solved by future observations. Mystery number 49 is about the shape of the universe. Is the universe flat, curved like a sphere, or curved like a saddle? This might sound like a strange question, but it's fundamentally about the geometry of space-time. Einstein's theory of general relativity tells us that mass and energy curve space-time, and the overall shape of the universe depends on how much total mass and energy it contains. If there's exactly the critical amount, the universe is flat, meaning parallel lines stay parallel forever. If there's more than the critical amount, the universe is closed, curving back on itself like the surface of a sphere. If there's less, the universe is open, curving like a saddle. Measurements of the cosmic microwave background radiation, the leftover light from the Big Bang, have allowed scientists to measure the geometry of the universe with remarkable precision. The results show that the universe is very close to flat, so close that we can't detect any curvature. But here's the mystery. Why is the universe so precisely flat? According to the Big Bang theory, the universe should have quickly evolved away from flatness, unless it started out extremely close to flat. The chances of this happening by random chance are astronomically small. This is called the flatness problem. The theory of cosmic inflation, a period of extremely rapid expansion in the first fraction of a second after the Big Bang, was partly developed to solve this problem. Inflation would have stretched the universe so much that any initial curvature would have been smoothed out, making it appear flat. But inflation itself raises questions and isn't fully understood. The universe's geometry is telling us something important about its history, and we're still working to understand the full picture. Mystery number 50 takes us to the question of the universe's missing antimatter. Antimatter is like a mirror image of normal matter. For every particle, there's an antiparticle with the same mass but opposite charge. An electron has a negatively charged antiparticle called a positron. A proton has an antiproton. When matter and antimatter meet, they annihilate each other in a burst of energy. According to the laws of physics as we understand them, the Big Bang should have created equal amounts of matter and antimatter. But when we look around the universe, we see mostly matter. Galaxies, stars, planets, people, all made of matter. There's very little antimatter. If there were significant amounts of antimatter in the universe, we'd see evidence of matter-antimatter annihilation at the boundaries between matter and antimatter regions, releasing telltale gamma rays. But we don't see this. So where did all the antimatter go? Why is there an asymmetry between matter and antimatter? This is one of the biggest unsolved problems in cosmology. Scientists think there must have been some process in the early universe that favored matter over antimatter, creating a slight imbalance. As the universe cooled, most of the matter and antimatter annihilated, but the tiny excess of matter survived and became everything we see today. But what caused this imbalance? The answer might involve physics beyond the standard model, new particles or forces that we haven't discovered yet. Scientists are studying this question with particle accelerators and cosmological observations, looking for clues about what happened in the first moments after the Big Bang. Mystery number 51 is about the Kuiper Belt and its unexpected structure. The Kuiper Belt is a region beyond Neptune filled with icy bodies, leftovers from the formation of the solar system. Pluto is the most famous Kuiper Belt object, but there are thousands of others. When scientists started mapping the Kuiper Belt in detail, they found something strange. The belt has a sharp outer edge at about 50 astronomical units from the Sun, 1 astronomical unit being the distance from Earth to the Sun. Beyond this edge, the number of objects drops off dramatically. This is called the Kuiper Cliff. The mystery is, why is there a cliff? Why doesn't the belt gradually thin out? Some scientists think the cliff might be evidence of a distant planet, Planet 9, whose gravity cleared out the outer regions of the Kuiper Belt. Others suggest it might be due to the way the solar system formed, with a lack of material in that region from the beginning. Or maybe objects beyond the cliff were scattered away by gravitational interactions with Neptune early in the solar system's history. The Kuiper Belt is also divided into different populations with different orbital characteristics. Some objects are in resonance with Neptune, meaning they orbit the Sun a certain number of times for every time Neptune orbits. Others have orbits that are highly tilted or very elliptical. Understanding how all these populations formed and why the belt has the structure it does is helping us learn about the early history of the solar system, about how planets migrated, and how small bodies were scattered into different orbits. The Kuiper Belt is a fossil record of the solar system's youth, and we're still reading that record. Mystery number 52 involves the atmosphere of Mars and its mysterious methane plumes. We talked earlier about the general mystery of methane on Mars, but there's a specific puzzle about how the methane behaves. Measurements from orbit and from the Curiosity rover on the surface show that methane concentrations vary dramatically. Sometimes there's almost no methane detectable, and at other times, concentrations spike to much higher levels. These spikes seem to happen at certain times and in certain locations. One possible explanation is that methane is being released from underground reservoirs in bursts, perhaps through cracks in the rock. But what controls the timing of these releases? Temperature changes, seismic activity, or seasonal effects might play a role, but we don't have enough data to be sure. Another mystery is that methane shouldn't last long in Mars's atmosphere. Ultraviolet light from the Sun should break it down within a few hundred years, so if we're detecting methane, it must be getting replenished somehow, either by ongoing geological processes or possibly by microbial life. The stakes are high because if life is producing the methane, that would be one of the most important discoveries in history. But proving that requires more data than we currently have. Future missions to Mars are planned to investigate the methane mystery more closely, drilling into the surface to look for organic compounds and searching for signs of active geology or biology. Mystery number 53 is about Saturn's moon Enceladus and its mysterious tiger stripes. We mentioned earlier that Enceladus has geysers erupting from its south pole, but the structure of that region is itself mysterious. The South Pole is marked by 4 long parallel cracks in the ice, nicknamed tiger stripes because of their appearance. These cracks are warmer than the surrounding terrain, and they're the source of the geysers. The mystery is why the tiger stripes are so regularly spaced and parallel. What geological process creates such an organized pattern? Scientists think the stripes might be places where the ice crust is being pulled apart by tidal forces from Saturn, and as the cracks open, water from the subsurface ocean escapes. But the regular spacing suggests there's some kind of feedback mechanism, where the formation of one crack affects where the next one forms. Similar patterns can be seen on Jupiter's moon Europa, where the ice crust is also active. Understanding these patterns helps us understand how icy moons respond to tidal forces and how subsurface oceans interact with the surface. Enceladus is a small moon, only about 300 miles across, but it's one of the most geologically active places in the solar system, and its south pole is the focus of intense scientific interest because of the possibility of life in its hidden ocean. Mystery number 54 takes us to the edge of the solar system and the heliopause. The heliopause is the boundary where the solar wind, the stream of particles flowing out from the sun, meets the interstellar medium, the gas and dust between stars. It's the edge of the sun's influence, the boundary between our solar system and interstellar space. NASA's Voyager 1 spacecraft crossed the heliopause in 2012, becoming the first human-made object to enter interstellar space. Voyager 2 followed in 2018. But when the Voyagers crossed the heliopause, they found it was more complex than expected. The boundary isn't a sharp line. It's more like a transition zone, with turbulent mixing of solar wind and interstellar material. The Voyagers also detected unexpected bursts of energetic particles and strange magnetic field behavior. The shape and location of the heliopause change over time as the solar wind varies with the sun's 11-year activity cycle. And there are structures beyond the heliopause that we don't fully understand, regions where cosmic rays are more or less intense, boundaries that might mark the outer edges of the sun's magnetic influence. The Voyagers are still sending back data, though they're so far away now that their signals take over 20 hours to reach Earth. They're exploring a region of space that no spacecraft has visited before, and every piece of data they send reveals new mysteries about the boundary between our solar system and the galaxy beyond. Mystery number 55 is about exoplanet atmospheres and the strange things we're finding. As technology has improved, astronomers have been able to study the atmospheres of planets orbiting other stars. They do this by watching the star's light pass through the planet's atmosphere during a transit, when the planet passes in front of its star from our point of view. Different gases in the atmosphere absorb light at different wavelengths, leaving a fingerprint that scientists can detect. What they've found is astonishing. Some exoplanets have atmospheres filled with clouds of vaporized rock or iron. Others have winds moving at thousands of miles per hour. One planet, called WASP-76b, has an atmosphere that appears to be almost completely transparent, with no clouds at all. Another, HD 189733b, has clouds of corundum, the mineral that forms rubies and sapphires, and winds that could create showers of gemstones raining from the sky. Scientists are also detecting water vapor, methane, and other molecules in exoplanet atmospheres. But here's the mystery. Some planets don't fit our models. Their atmospheres are too puffy, too dense, or have the wrong composition based on what we think we know about planet formation. This is forcing scientists to revise theories about how planets form and evolve. Every new exoplanet atmosphere we study teaches us something, and often it's something unexpected, something that challenges our understanding. Mystery number 56 involves strange radio signals from space called periton. These signals were detected by the Parkes Radio Telescope in Australia over several years. They looked similar to fast radio bursts, those mysterious pulses of radio waves from distant galaxies. But peritons were different. They showed up in multiple telescope beams at once, which meant they were coming from nearby, not from deep space. For a long time, their origin was a mystery. Were they from Earth-based interference, Or were they some kind of atmospheric phenomenon? In 2015, scientists finally figured it out. Peritons were being caused by microwave ovens. When someone opened the microwave door before the timer finished, the microwave would emit a burst of radio waves that the telescope detected. It sounds funny, but it highlights a real challenge in radio astronomy. Distinguishing genuine astronomical signals from interference from human technology is difficult. Radio telescopes have to filter out signals from cell phones, satellites, radar, and all sorts of electronic devices. Every mysterious signal has to be carefully investigated to determine if it's real or just noise. The peritons turned out to be microwave ovens, but the investigation process helped scientists develop better methods for identifying and eliminating interference, making it easier to spot genuine cosmic signals. Mystery number 57 is about the hexagonal storm at Saturn's North Pole, which we mentioned briefly before, but there's more to this mystery. The hexagon isn't just a static feature, it rotates with Saturn's atmosphere, completing one rotation every 10 hours and 39 minutes. But Saturn's rotation period, as measured by its magnetic field, is slightly different, about 10 hours and 47 minutes. This mismatch is strange. On Earth, we can measure the planet's rotation by watching the surface, but Saturn is a gas giant with no solid surface. Scientists measure its rotation by tracking its magnetic field, which is generated deep inside the planet. The fact that the hexagon rotates at a different rate than the magnetic field suggests that different layers of Saturn's atmosphere rotate at different speeds. This is called differential rotation, and it's common on gas giants, but the exact mechanisms driving it aren't fully understood. The hexagon also changes color with the seasons. During Saturn's northern winter, the hexagon was a golden color, but as spring arrived, it shifted to a more bluish hue. This color change might be due to increased sunlight causing chemical reactions in the atmosphere, producing or destroying haze particles. Saturn's hexagon is a long-lived atmospheric feature that's teaching us about the complex dynamics of gas giant atmospheres, but it still holds mysteries. Mystery number 58 takes us to the volcanoes of Venus. Venus has more volcanoes than any other planet in the solar system, with over 1,600 major volcanoes, and probably many more smaller ones. Most of these volcanoes appear to be inactive now, but there's evidence that some might have erupted relatively recently in geological terms. The mystery is Venus still volcanically active today? Scientists have looked for signs of recent eruptions, and there are hints. Some regions of Venus's surface look very fresh, with lava flows that appear to be only a few million years old, which is young in geological time. The European Space Agency's Venus Express spacecraft detected variations in sulfur dioxide in Venus's atmosphere that could be explained by volcanic eruptions releasing gas, and recent analysis of old data from NASA's Magellan mission found changes in the shape of a volcano over a period of months, suggesting lava might have been flowing. But we don't have definitive proof of active volcanism. Venus is hard to study because of its thick clouds, and we haven't had a dedicated Venus surface mission in decades. Future missions are planned, including orbiters and possibly landers, that will search for active volcanoes. If Venus is volcanically active, it would make it one of only 4 bodies in the solar system with confirmed active volcanism, along with Earth, Jupiter's moon Io, and Saturn's moon Enceladus. Understanding Venus's volcanic activity would help us understand the planet's interior and its geological history. Mystery number 59 is about planetary migration in our solar system. For a long time, scientists assumed that the planets formed in their current positions and have stayed there ever since. But evidence has accumulated that the giant planets, Jupiter, Saturn, Uranus, and Neptune, didn't always orbit where they do now. They migrated, moving inward or outward, over millions of years after they formed. This migration was driven by gravitational interactions with the disk of gas and dust that surrounded the young sun, and later by interactions with the countless small bodies left over from planet formation. The most dramatic version of this idea is called the NICE model, named after the city in France where it was developed. According to the NICE model, the giant planets formed closer together than they are now. About 4 billion years ago, a gravitational instability caused them to scatter, with Jupiter moving slightly inward and the other giants moving outward. This migration caused chaos in the outer solar system, scattering icy bodies in all directions. Some fell inward, bombarding the inner planets in an event called the Late Heavy Bombardment. Others were flung outward, forming the Kuiper Belt and the Oort cloud. The NICE model explains many features of the solar system, but the details are still debated. Exactly when did the migration happen? How long did it take? Did the planets' orbits become elliptical before settling into their current near-circular shapes? These are questions that simulations are trying to answer, and each new piece of evidence from meteorites, asteroids, and planetary surfaces helps refine our understanding. Mystery number 60 involves the moons of Uranus and their strange tilts. Uranus is tilted on its side, which we've discussed, and its moons orbit around its equator, aligned with the planet's tilt. But when scientists look closely at the orbits of Uranus's moons, they find small irregularities, slight tilts and wobbles that don't quite fit the simple picture. These irregularities suggest that the moons might have experienced complicated interactions in the past, perhaps with other moons that no longer exist, or with rings that have since dissipated. Uranus has a faint ring system, much less prominent than Saturn's, and the rings and moons interact gravitationally. Some of Uranus's small inner moons act as shepherd moons, using their gravity to keep the rings confined. But the system is unstable. Computer simulations suggest that some of Uranus's inner moons might collide with each other in the future, perhaps in a few million years. These collisions would create debris that could form new rings or coalesce into new moons. Uranus's moon system is dynamic, constantly evolving, and scientists are trying to understand its past and predict its future. The fact that the entire system is tilted on its side adds an extra layer of complexity, making Uranus one of the most unusual and mysterious planets in the solar system. Mystery number 61 is about the atmosphere of Titan and its complex chemistry. Titan's atmosphere is mostly nitrogen like Earth's, but it also contains methane and small amounts of other organic compounds. When sunlight hits the upper atmosphere, it breaks apart methane molecules, and the fragments recombine to form more complex molecules, creating a thick orange haze that obscures the surface. Scientists have detected dozens of different organic molecules in Titan's atmosphere, including ethane, propane, benzene, and even more complex compounds called tholins. These are the building blocks of life, the same kinds of molecules that might have existed in Earth's early atmosphere. The mystery is how complex this chemistry gets. Some scientists think that really complex molecules, possibly even amino acids, might be forming in Titan's atmosphere and raining down onto the surface. Over billions of years, Titan's surface might have accumulated a layer of these organic compounds, a rich chemical treasure trove. But we can't see the surface clearly because of the haze, and we've only landed one probe there, the Huygens probe, which operated for just a few hours before its batteries died. Future missions might include a drone or a submarine to explore Titan's lakes and seas, searching for complex organic chemistry and possibly even some form of life. Titan is like a frozen version of early Earth, and studying it might help us understand how life began on our own planet. Mystery number 62 involves the metallic hydrogen core of Jupiter. Jupiter is made mostly of hydrogen and helium, the same elements that make up the Sun. But unlike the Sun, Jupiter isn't massive enough for nuclear fusion to occur in its core. Instead, the pressure deep inside Jupiter is so enormous that hydrogen behaves in a strange way. Under extreme pressure, hydrogen atoms are squeezed so tightly together that their electrons break free and move around like they do in a metal. This is called metallic hydrogen, and it's thought to exist deep inside Jupiter, forming a thick layer around the planet's core. Metallic hydrogen has never been created in a laboratory under controlled conditions for more than a brief instant. The pressures required are simply too high for current technology. So everything we think we know about Jupiter's interior comes from theoretical models and indirect observations, like measurements of Jupiter's magnetic field and gravitational field. The mystery is, what exactly is happening in Jupiter's core? Is there a solid core of rock and ice at the very center, surrounded by metallic hydrogen, or is the core dissolved into the metallic hydrogen layer? How thick is the metallic hydrogen layer, and what are its properties? NASA's Juno spacecraft has been measuring Jupiter's gravitational and magnetic fields with unprecedented precision, and these measurements are helping scientists refine their models of the interior. But we'll never be able to see inside Jupiter directly. We have to infer the structure from the data we can collect, and that means some uncertainty will always remain. Mystery number 63 is about interstellar visitors. We talked about Oumuamua earlier, the first confirmed interstellar object to pass through our solar system. But since then, astronomers have detected another one. In August 2019, an amateur astronomer discovered a comet that turned out to have come from outside the solar system. It was named Borisov, after its discoverer. Unlike Oumuamua, Borisov looked like a normal comet with a tail of gas and dust. Scientists around the world studied it intensely as it passed through the inner solar system, using telescopes to analyze its composition. They found that Borisov was similar to comets from our own solar system, but with some differences. It had higher concentrations of carbon monoxide than most solar system comets, which might tell us something about the conditions in the star system where it formed. The discovery of two interstellar objects in just a few years suggests that these visitors might be more common than we thought. There might be interstellar asteroids and comets passing through the solar system all the time, but most of them are too small or too faint for us to detect. Advanced telescopes like the upcoming Vera Rubin Observatory will scan the sky more thoroughly and might detect many more of these objects. Each one is a messenger from another star system, carrying information about planetary systems beyond our own. The mystery is, how common are these objects, where do they come from, and what can they tell us about planet formation around other stars? Mystery number 64 involves Earth's water and where it came from. Earth is a watery planet, with oceans covering more than 70% of the surface. But where did all this water come from? Earth formed in the inner solar system, close to the Sun, where it was too hot for water ice to exist. The rocky material that clumped together to form Earth should have been dry, so the water must have been delivered later, after Earth formed. The leading candidates are comets and asteroids. Comets are icy bodies from the outer solar system, and if enough comets hit Earth, they could have brought water. Asteroids, especially those from the outer asteroid belt, also contain water, locked up in minerals. The mystery is figuring out which source contributed more. Scientists have tried to answer this by comparing the type of water on Earth with the type of water in comets and asteroids. Water molecules come in different varieties, or isotopes, depending on whether the hydrogen atoms are normal hydrogen or deuterium, a heavier form. Earth's water has a specific ratio of normal hydrogen to deuterium, and by measuring this ratio in comets and asteroids, scientists can see which matches best. So far, the results suggest that asteroids are a better match than comets, but it's not definitive. There might have been contributions from both sources, and the water Earth received might have come from a mix of objects. Understanding where Earth's water came from helps us understand how habitable planets form and whether water delivery is a common process on rocky planets around other stars. Mystery number 65 is about the strange behavior of comets. Comets are icy bodies that spend most of their time in the cold outer regions of the solar system. When they swing close to the Sun, the ice heats up and sublimates, turning directly from solid to gas, creating the beautiful tail we associate with comets. But comets sometimes do unexpected things. Some comets brighten suddenly, flaring up for reasons that aren't clear. Others split apart, breaking into multiple pieces. In 2020, a comet called Atlas broke into more than 30 fragments as it approached the Sun. Scientists aren't sure why. It might have been weakened by repeated passes near the Sun, or it might have been hit by a meteoroid, or internal stresses from outgassing might have torn it apart. Another mystery is why some comets are much more active than others. Two comets with similar orbits and similar compositions can behave very differently when they approach the Sun. One might develop a bright, spectacular tail while the other barely shows any activity. This suggests that the internal structure of comets, how the ice and dust are arranged inside, matters a lot. But we can't see inside comets. We can only observe their surfaces and the gas and dust they release. A few space missions have visited comets up close, including the Rosetta mission, which orbited a comet for 2 years and even landed a probe on its surface. These missions have revealed that comets are more complex than we thought, with layered structures, varied compositions, and active regions that turn on and off. Every comet is different, and each one teaches us something new. Mystery number 66 involves neutrino oscillations. Neutrinos are tiny, nearly massless particles that are produced in huge numbers by nuclear reactions in the Sun and in supernovas. Trillions of neutrinos pass through your body every second, but they barely interact with anything. They can pass through the entire Earth without hitting a single atom. For a long time, scientists thought neutrinos had no mass at all, but experiments starting in the late 1990s showed that neutrinos can change from one type to another as they travel. There are 3 types, or flavors, of neutrinos, and they oscillate between these flavors. This oscillation can only happen if neutrinos have a tiny bit of mass. The discovery of neutrino oscillations won the Nobel Prize in Physics in 2015 because it was the first clear evidence of physics beyond the Standard Model, the theory that describes all known particles and forces. But the mystery is, how much mass do neutrinos have? We know it's very small, less than a millionth the mass of an electron, but we don't know the exact value. We also don't know why neutrinos have mass or what gives them mass. The mechanism that gives mass to other particles, the Higgs field, might not work the same way for neutrinos. There might be additional particles or fields we haven't discovered yet. Scientists are conducting experiments to measure neutrino mass more precisely and to understand the properties of these elusive particles. Neutrinos are everywhere, streaming through the universe, and understanding them better might reveal new fundamental physics. Mystery number 67 is about the rotation of Mercury. Mercury rotates very slowly, taking 59 Earth days to complete one rotation. But here's what's strange. Mercury's day is locked in a 3:2 resonance with its year. Mercury orbits the Sun in 88 Earth days, so it completes exactly 3 rotations for every 2 orbits. This is unusual. Most moons in the solar system are tidally locked to their planets, showing the same face all the time, like Earth's moon. But Mercury isn't tidally locked. It's in a spin-orbit resonance. The mystery is why. Scientists think it has to do with Mercury's elliptical orbit and the distribution of mass inside the planet. Mercury's orbit is more elliptical than any other planet's, and as it moves closer to and farther from the Sun's gravity tugs on it differently. These tugs, combined with the way mass is distributed inside Mercury, have locked the planet into this 3:2 resonance. But the details are complex, and small changes in Mercury's interior structure or past orbital history could have resulted in a different outcome. Understanding Mercury's rotation helps us understand tidal forces and how planets and moons evolve over time. The 3:2 resonance means that if you stood on Mercury's surface, you would see the Sun rise, move partway across the sky, then reverse direction and set where it rose, then rise again, and move all the way across the sky before setting on the opposite horizon. The motion of the Sun in Mercury's sky is unlike anywhere else in the solar system. Mystery number 68 takes us to rogue planets, planets that don't orbit any star. They're drifting through space on their own, untethered, dark and cold. Astronomers have discovered several of these rogue planets, detecting them by their infrared glow or by the way they briefly brighten a background star through gravitational lensing. The mystery is how common these rogue planets are and where they came from. Some might have formed in orbit around a star and then been ejected by gravitational interactions with other planets. Others might have formed on their own in interstellar space, condensing from gas clouds without ever being part of a planetary system. If rogue planets are common, and some estimates suggest there might be billions of them in our galaxy, then they represent a significant population of objects that we're only beginning to discover. Some rogue planets might be large, gas giants like Jupiter. Others might be smaller, rocky planets like Earth. Without a star to warm them, these planets would be frozen, their surfaces coated in ice, their atmospheres, if they have any, collapsed and frozen on the ground. But deep inside, some rogue planets might still have heat from their formation or from radioactive decay. If they have thick enough atmospheres or subsurface oceans heated by internal energy, they might even harbor life, surviving in the darkness of interstellar space without a sun. It's a speculative idea, but it's not impossible. The universe might be full of wandering worlds, invisible nomads drifting between the stars. Mystery number 69 is about the Parker Solar Probe and the Sun's mysteries. NASA's Parker Solar Probe is flying closer to the Sun than any spacecraft before, diving through the corona to take measurements in the most extreme environment we've ever explored. The spacecraft is protected by a heat shield that keeps its instruments cool even as the shield itself heats to over 2,000 degrees Fahrenheit. The probe is studying the solar wind, the stream of charged particles flowing out from the Sun, and it's trying to solve the mystery of how the solar wind is accelerated. Near the Sun, the solar wind is relatively slow, but as it moves away, it speeds up dramatically. Something is accelerating it, adding energy, but we're not sure what. The Parker Solar Probe has already made surprising discoveries. It found that the Sun's magnetic field switches direction more often than expected, creating kinks and switchbacks in the field. These switchbacks might be connected to the acceleration of the solar wind. The probe has also flown through structures in the corona, measuring their temperature and composition directly. Each close approach to the Sun, called a perihelion, brings new data and new insights. The mission will continue for several more years, with the spacecraft flying closer and closer to the Sun, eventually passing within 4 million miles of the surface. These observations are revolutionizing our understanding of the Sun and stars in general, teaching us about the fundamental processes that power stellar atmospheres and drive space weather. Mystery number 70 involves the strange orbit of Sedna. Sedna is a distant object in the outer solar system, far beyond Pluto. It was discovered in 2003, and its orbit is extremely elliptical. At its closest, Sedna comes within 76 astronomical units of the Sun, still much farther than Neptune. At its farthest, it travels more than 900 astronomical units away, taking over 11,000 years to complete one orbit. The mystery is, how did Sedna get into this orbit? Its closest approach is too far for Neptune's gravity to have scattered it there, and its orbit is too elliptical to have formed where it is. Something must have influenced Sedna, pulling it into this strange path. Some scientists think a passing star might have tugged on Sedna billions of years ago, when the Sun was still in the crowded stellar nursery where it formed. Others suggest that Planet 9, if it exists, might be responsible. Another idea is that the Sun might have once had a binary companion, another star that has since drifted away, and the companion's gravity shaped Sedna's orbit. There are also a few other objects with similar orbits, forming what some astronomers call the inner Oort cloud. These objects are telling us something about the early solar system and the influences that shaped it. Sedna is a frozen world on the edge of the abyss, and its lonely orbit holds clues to events that happened billions of years ago. Mystery number 71 is about the Moon's far side. The far side of the Moon, often incorrectly called the dark side, is the hemisphere we never see from Earth because the Moon is tidally locked, always showing us the same face. When spacecraft first photographed the far side, they revealed a surface that looks very different from the near side. The far side has many more craters and far fewer of the dark, smooth plains called Maria that dominate the near side. The mystery is, why is the far side so different? The maria on the near side are made of basalt, volcanic rock that flowed out billions of years ago and filled large impact basins. But the far side has very few maria, which means it had much less volcanic activity. Scientists think this might be because the crust is thicker on the far side, making it harder for magma to reach the surface. But why is the crust thicker? One idea is that the moon formed from a giant impact between Earth and another planet-sized object, and the side facing Earth cooled more slowly because it was heated by Earth's radiation, resulting in a thinner crust. Another idea involves the distribution of heat producing radioactive elements in the moon's interior. The far side of the moon remains less explored than the near side. Only a few missions have landed there, including China's Chang'e 4 mission, which landed in the South Pole Aitken Basin, one of the largest impact craters in the solar system. Each mission to the far side reveals more about this mysterious and ancient terrain. Mystery number 72 involves the peculiar rotation of Venus's atmosphere. While Venus itself rotates very slowly, taking 243 days to spin once, the atmosphere rotates much faster. Winds in Venus's upper atmosphere circle the planet in only 4 days, a phenomenon called superrotation. This means the atmosphere is moving about 60 times faster than the planet's surface. The mystery is, what drives these incredibly fast winds? On Earth, the atmosphere rotates at about the same speed as the surface, because friction between the ground and the air keeps them coupled. But on Venus, the thick atmosphere has somehow decoupled from the surface and spun up to enormous speeds. Scientists think the heating from the sun plays a role, creating temperature differences that drive the winds, but the exact mechanism isn't clear. Computer models of Venus's atmosphere struggle to reproduce the superrotation accurately. There are also strange features in the atmosphere, like a giant vortex at each pole, swirling structures that look like hurricanes but are driven by different physics. Venus's atmosphere is a laboratory for studying extreme atmospheric dynamics, and understanding it better helps us understand atmospheres in general, including those of exoplanets that might have similar conditions. Mystery number 73 is about gravitational waves and their sources. Gravitational waves are ripples in spacetime caused by accelerating masses. Einstein predicted them over a century ago, but they weren't directly detected until 2015, when the LIGO observatories measured waves from the collision of 2 black holes. Since then, dozens of gravitational wave events have been detected, from black hole mergers, neutron star mergers, and possibly other sources. But there are mysteries. Some of the black holes we're detecting are heavier than we expected. Stellar mass black holes form from the collapse of massive stars, and based on our understanding of stellar evolution, there should be a gap in the mass range where black holes don't form. But LIGO has detected black holes in this forbidden mass range. How did they get so heavy? They might have formed from the merger of smaller black holes, or there might be formation mechanisms we don't understand. Another mystery is whether there are gravitational waves from other sources we haven't detected yet. Supernova explosions should produce gravitational waves if they're asymmetric, but we haven't detected any yet. There might also be a background hum of gravitational waves from countless sources throughout the universe, a cosmic background similar to the cosmic microwave background radiation. Scientists are working to detect this background and to identify new types of sources. Gravitational wave astronomy is still very new, and every detection teaches us something unexpected. Mystery number 74 involves the Tunguska event. On June 30th, 1908, a massive explosion occurred over Siberia, flattening 80 million trees over an area of 800 square miles. The explosion was about 1,000 times more powerful than the atomic bomb dropped on Hiroshima. But when scientists traveled to the site years later, they found no crater. The leading explanation is that a small asteroid or comet exploded in the atmosphere before hitting the ground. The shockwave from the explosion was powerful enough to knock down trees but not to create a crater. But the mystery is, what exactly was the object, and why did it explode in the air? Calculations suggest it was probably a stony asteroid about 120 feet across, traveling at tens of thousands of miles per hour. The heat and pressure from atmospheric friction would have caused it to break apart and explode, but we have no fragments to study, no direct evidence of what it was. The Tunguska event reminds us that Earth is vulnerable to impacts from space, and even relatively small objects can cause enormous damage if they hit a populated area. Scientists are now tracking near-Earth asteroids and developing plans to deflect any that pose a threat. But objects the size of the Tunguska impactor are hard to detect in advance. Mystery number 75 is about the unusual properties of water. Water is one of the most common substances in the universe, made of hydrogen and oxygen, two of the most abundant elements. But water has strange properties that make it different from other liquids. It's one of the few substances that expands when it freezes, which is why ice floats on water. This property is crucial for life on Earth because if ice sank, lakes and oceans would freeze from the bottom up, making it much harder for aquatic life to survive. Water also has an unusually high heat capacity, meaning it takes a lot of energy to change its temperature. This helps regulate Earth's climate, with the oceans absorbing and releasing heat slowly. And water is an excellent solvent, able to dissolve more substances than almost any other liquid, which makes it essential for chemistry and biology. The mystery is why water has these properties. They arise from the way water molecules interact with each other through hydrogen bonds, weak attractions between the hydrogen of one molecule and the oxygen of another. These bonds give water its unique characteristics, but the details of how they work, especially in different temperatures and pressures, are still being studied. Scientists use computer simulations to model water at the molecular level, trying to understand everything from how ice forms to how water behaves in extreme environments like the deep ocean or inside icy moons. Water is essential for life as we know it, and understanding it better helps us understand where else in the universe life might exist. Mystery number 76 involves fast radio bursts and their repeating patterns. We talked earlier about fast radio bursts in general, but there's a specific mystery about the ones that repeat. Most fast radio bursts are one-time events, a single flash that's never seen again, but a few sources repeat, sending out bursts at irregular intervals. One source, called FRB 121102, has a repeating pattern. It's active for about 4 days, sending out multiple bursts, then goes silent for 12 days, then becomes active again. This 16-day cycle has repeated multiple times, suggesting there's something regular about the source. The mystery is, what kind of object or system could produce such a pattern? One idea is that the source is a neutron star in a binary orbit with another star, and the 16-day period is the orbital period. As the neutron star orbits, it might pass through the other star's stellar wind or disk of material, triggering the bursts. But this is speculative. Another repeating source doesn't follow a regular pattern at all, sending bursts randomly. This suggests there might be different types of sources for fast radio bursts, or different mechanisms at work. Each new repeating fast radio burst we detect gives us more clues, but the picture is still incomplete. These are some of the most energetic and mysterious events in the universe, and we're racing to understand them. Mystery number 77 is about the structure of the Oort cloud. The Oort cloud is a hypothetical shell of icy objects surrounding the solar system, extending from about 2,000 astronomical units out to perhaps 100,000 astronomical units or more, nearly halfway to the nearest star. The Oort cloud has never been directly observed because the objects in it are too small and too far away to see, but we infer its existence from the comets that occasionally fall inward toward the sun. Long-period comets, those that take hundreds or thousands of years to orbit the sun, come from the Oort cloud. Their orbits point back to this distant region. The mystery is how the Oort cloud formed and what its structure is. Scientists think it was created from icy debris left over from the formation of the planets. Gravitational interactions with the giant planets flung these objects into distant orbits, creating the Oort cloud. But we don't know how many objects are there, how they're distributed, or whether the Oort cloud is spherical or more like a disk. Some models suggest there might be an inner Oort cloud and an outer Oort cloud with different populations. The Oort cloud marks the edge of the Sun's gravitational influence, the outermost frontier of the solar system, and it's a realm we've barely begun to explore. Mystery number 78 involves cosmic microwave background anomalies. The cosmic microwave background radiation is the most important source of information about the early universe. It's incredibly uniform, with temperature variations of only about 1 part in 100,000. But when scientists map these tiny variations in detail, they find some features that don't quite fit the standard model of cosmology. One is the cold spot we mentioned earlier. Another is something called the axis of evil, a name given to an apparent alignment of the largest temperature fluctuations in the microwave background. According to the standard model, these fluctuations should be randomly oriented, but they seem to be aligned with each other and with the plane of the solar system. This is very strange and might just be a statistical fluke, but it's puzzling. Another anomaly is that the microwave background looks slightly different in different directions in ways that aren't fully explained. Some scientists think these anomalies might be hints of new physics, perhaps evidence that the universe is more complex than our models assume. Others think they're just noise or artifacts of the way we analyze the data. Resolving these anomalies requires more precise measurements and better theoretical models, and future missions are planned to study the cosmic microwave background in even greater detail. Mystery number 79 is about the origin of Earth's moon. The leading theory is that the moon formed from debris created when a Mars-sized object called Theia collided with Earth about 4.5 billion years ago. The impact threw a huge amount of material into orbit around Earth, and this material gradually coalesced to form the moon. This giant impact hypothesis explains many features of the Earth-Moon system, like the moon's relatively low density and the fact that it's depleted in volatile elements. But there are problems. When scientists model the collision, they find that most of the material that forms the moon should come from Theia, not from Earth. But when we analyze moon rocks brought back by the Apollo astronauts, we find that the isotopic composition of the moon is almost identical to Earth's. If the moon formed mostly from Theia, it should have a different composition. This is called the isotope problem. Scientists have proposed various solutions. Maybe Theia formed in the same region of the solar system as Earth and had the same composition to begin with. Or maybe the impact mixed the material so thoroughly that Earth and Theia's material became indistinguishable. Or maybe the impact vaporized so much material that it created a shared atmosphere between Earth and the newly forming moon, allowing the isotopes to equilibrate. These are active areas of research, and new simulations and new analyses of moon rocks are refining our understanding of how the moon formed. Mystery number 80 takes us to Jupiter's Great Cold Spot. We talked about Jupiter's Great Red Spot earlier, but there's also a Great Cold Spot, discovered only recently. It's located in Jupiter's upper atmosphere and is much colder than the surrounding area, about 200 degrees Fahrenheit colder. Unlike the Great Red Spot, which is a visible storm, the Great Cold Spot is invisible to optical telescopes. It was discovered using infrared observations that measure temperature. The mystery is what creates this cold region. Scientists think it's related to Jupiter's powerful auroras. The auroras at Jupiter's poles are driven by interactions between Jupiter's magnetic field and charged particles, and they heat the upper atmosphere. This heating drives winds that create regions of compression and expansion. In the expanded regions, the gas cools, creating the Great Cold Spot, but the exact mechanisms are still being worked out. The Great Cold Spot also changes size and shape over time, sometimes disappearing and reappearing. It's a dynamic feature driven by complex interactions between Jupiter's magnetic field, its atmosphere, and the charged particles trapped in its magnetosphere. Understanding it helps us understand the upper atmospheres of gas giant planets, both in our solar system and around other stars. Mystery number 81 is about the strange magnetic field of Ganymede. Ganymede is Jupiter's largest moon, and it's the only moon in the solar system known to have its own magnetic field. This is unusual because magnetic fields are typically generated by the motion of liquid metal in a planet's core, and moons are usually too small to have this kind of internal activity. But Ganymede is large, larger than the planet Mercury, and scientists think it has a liquid iron core that generates its magnetic field. This field creates a magnetosphere around Ganymede, a protective bubble that shields part of the moon from Jupiter's much stronger magnetic field. The mystery is what this tells us about Ganymede's interior. Having a magnetic field means Ganymede's core must still be hot enough to keep the iron molten, which suggests the moon has more internal heat than we might expect. There might be radioactive elements in the core providing heat, or tidal heating from Jupiter might be playing a role. Ganymede is also thought to have a subsurface ocean beneath its icy crust, sandwiched between layers of ice. Understanding the magnetic field helps us map the interior structure and figure out whether this ocean could potentially harbor life. Ganymede is a world of layers, ice and rock, and metal and possibly liquid water, and its magnetic field is one of the clues helping us understand this complex structure. Mystery number 82 involves the habitability of tidally locked planets. Many exoplanets orbit very close to their stars, so close that they're tidally locked, always showing the same face to their star, just like the moon shows the same face to Earth. This means one side of the planet is in permanent daylight, constantly baked by the star's heat, while the other side is in permanent darkness, freezing cold. For a long time, scientists thought such planets couldn't support life. The day side would be too hot, the night side too cold, and any atmosphere would freeze out on the night side. But recent climate models suggest that tidally locked planets might be more habitable than we thought. If the planet has an atmosphere, winds would circulate heat from the day side to the night side, potentially creating a band along the terminator, the boundary between day and night, where temperatures are moderate. This twilight zone could be a habitable region, perhaps even more stable than conditions on Earth, because there are no seasons and the temperature stays constant. Some models even suggest that water could exist in liquid form in this region. The mystery is whether real tidally locked planets have thick enough atmospheres to redistribute heat effectively, and whether life could actually survive in such an environment. Astronomers are searching for biosignatures on these planets, looking for signs of life in their atmospheres, using telescopes that can analyze the light filtering through when the planet transits its star. Mystery number 83 is about the unexpected discovery of phosphine in Venus's atmosphere. In 2020, scientists announced they had detected phosphine gas in Venus's clouds. Phosphine is a molecule made of phosphorus and hydrogen, and on Earth, it's mostly produced by biological processes or by human industry. Finding it on Venus was shocking because Venus is incredibly hostile to life, with surface temperatures hot enough to melt lead and atmospheric pressure 90 times greater than Earth's. But the clouds of Venus, high in the atmosphere, have conditions that are more temperate, with temperatures and pressures similar to Earth's surface. Could there be microbes floating in Venus's clouds producing phosphine? The discovery sparked intense debate. Some scientists questioned whether the phosphine detection was real or if it might be a different molecule being misidentified. Others proposed non-biological ways phosphine could be produced, like volcanic activity or chemical reactions driven by lightning or sunlight. Follow-up observations with other telescopes have given mixed results. Some confirmed the phosphine signal, others didn't detect it. The mystery remains unresolved. If phosphine is really there, and if it's being produced by life, it would be one of the most important discoveries in history. But extraordinary claims require extraordinary evidence, and scientists are being very careful to verify the detection and explore all possible explanations before jumping to conclusions. Mystery number 84 involves the orbit of Neptune's moon Triton, which we touched on earlier, but there's more to this story. Triton orbits Neptune backward, and it's gradually spiraling inward. In about 3.5 billion years, Triton will get close enough to Neptune that the planet's gravity will tear it apart, creating a spectacular ring system around Neptune, possibly even more impressive than Saturn's rings. But the mystery is what will happen before that. As Triton spirals inward, Neptune's gravity will pull on it more and more strongly, creating tidal stresses. These stresses will heat Triton's interior, possibly increasing its geological activity. We might see more geysers, more surface changes, more evidence of a subsurface ocean if one exists, and the tidal forces might cause Triton to break apart before it reaches the Roche limit, the distance at which tidal forces overcome the moon's own gravity. If Triton breaks apart gradually, it could create a ring system over millions of years rather than all at once. Watching Triton's orbit decay and predicting exactly what will happen is a fascinating exercise in celestial mechanics. We're witnessing the slow-motion destruction of a moon, and it gives us insight into how ring systems form and how moons evolve. Mystery number 85 is about the faint young sun paradox. When the sun first formed 4.5 billion years ago, it was about 30% dimmer than it is today. Stars brighten as they age, because nuclear fusion gradually changes their internal structure. The problem is, if the sun was so much dimmer, Earth should have been frozen. The amount of sunlight reaching Earth would have been too weak to keep water liquid. And yet, we have geological evidence that liquid water existed on Earth's surface as far back as 4 billion years ago. There are ancient rocks that clearly formed in the presence of water, sedimentary rocks and minerals that only form in liquid water. This is the faint young sun paradox. How was Earth warm enough for liquid water when the sun was so dim? The leading explanation is greenhouse gases. Earth's early atmosphere might have contained much higher levels of carbon dioxide, methane, or other greenhouse gases that trapped heat and kept the planet warm. Over time, as the sun brightened, the concentration of these gases decreased, keeping Earth's temperature relatively stable, but the details are uncertain. We don't know exactly what the composition of Earth's early atmosphere was, and computer models struggle to find combinations of greenhouse gases that work perfectly. Another idea is that Earth's albedo, its reflectivity, was lower in the past, perhaps because there were fewer clouds or less ice, allowing the planet to absorb more of the weak sunlight. The faint young sun paradox is a reminder that Earth's climate is a delicate balance of many factors, and understanding how it has changed over billions of years helps us understand climate change today. Mystery number 86 involves the strange chemistry of Enceladus's plumes. We've talked about Enceladus's geysers before, but detailed analysis of the material in the plumes has revealed something surprising. The plumes contain molecular hydrogen, H2, along with water vapor, carbon dioxide, methane, and complex organic molecules. The presence of molecular hydrogen is significant because on Earth, it's often associated with hydrothermal vents, places where hot water from Earth's interior meets the cold ocean, creating chemical reactions that produce hydrogen. These hydrothermal vents on Earth are teeming with life, ecosystems based not on sunlight but on chemical energy. The fact that Enceladus's plumes contain hydrogen suggests there might be similar hydrothermal activity on the Moon's ocean floor. Warm water from Enceladus's interior, heated by tidal forces, might be reacting with rocks, producing hydrogen and other chemicals. These chemicals could provide energy for microbial life, if it exists. The mystery is whether life has actually arisen in Enceladus's ocean. We have the ingredients, liquid water, chemical energy, and organic molecules. But having the ingredients doesn't guarantee life. Scientists are planning future missions to fly through Enceladus's plumes and collect samples, analyzing them for more complex organic molecules, or even for direct signs of life like amino acids, arranged in patterns that only biology produces. Enceladus is one of the most promising places in the solar system to search for life beyond Earth. Mystery number 87 is about the unexpected discovery of water on asteroids. Asteroids are supposed to be dry, rocky, or metallic bodies, relics from the early solar system that never accumulated enough material to become planets. But in recent years, scientists have found evidence of water on several asteroids. The Dawn spacecraft detected water ice and hydrated minerals on Ceres, which we discussed earlier. But even smaller asteroids show signs of water. Some asteroids have been observed releasing plumes of water vapor, acting almost like comets even though they're in the asteroid belt, not the outer solar system where we expect icy bodies. These objects are sometimes called main belt comets. The mystery is where this water came from and how it has survived for billions of years. Asteroids are exposed to sunlight, which should have evaporated any surface ice long ago. The water must be protected somehow, buried beneath the surface or trapped in minerals. Understanding how water persists on asteroids helps us understand how water was distributed throughout the early solar system and how it might have been delivered to Earth. If asteroids contain significant amounts of water, they could be valuable resources for future space exploration, providing water for astronauts and fuel for spacecraft without having to bring it from Earth. Mystery number 88 involves the speed of the universe's expansion. In the 1920s, astronomer Edwin Hubble discovered that the universe is expanding, with galaxies moving away from each other. The speed of this expansion is described by a number called the Hubble constant. For decades, astronomers have been trying to measure the Hubble constant more and more precisely. But in recent years, a problem has emerged. Different methods of measuring the Hubble constant give different answers. When scientists measure the expansion rate by studying the cosmic microwave background radiation, they get one value. When they measure it by looking at nearby galaxies and supernovas, they get a different value, about 9% higher. This might not sound like a big difference, but in science, a 9% discrepancy is huge, and it's been confirmed by multiple independent measurements. This is called the Hubble tension. The mystery is, which measurement is right, or are they both right and telling us something unexpected about the universe? Maybe the universe's expansion rate has changed over time in ways we don't understand. Maybe dark energy behaves differently than we think. Maybe there's new physics we haven't discovered yet. Or maybe there's a subtle error in one of the measurement methods that we haven't identified. Resolving the Hubble tension is one of the biggest challenges in cosmology right now, and it might require rethinking fundamental aspects of our cosmological models. Mystery number 89 is about the composition of Uranus and Neptune. These two planets are often called ice giants because they're thought to be made mostly of water, methane, and ammonia ices, along with rock and a small amount of hydrogen and helium. But we've never actually sampled their interiors. Everything we think we know comes from observations of their masses, sizes, and gravitational fields, combined with theoretical models. The mystery is what's really inside them. Recent experiments recreating the extreme pressures and temperatures inside these planets have shown that the chemistry might be much more complex than we thought. Under high pressure, water might separate into hydrogen and oxygen, forming superionic ice, a strange state where oxygen atoms are locked in place but hydrogen atoms flow freely, conducting electricity like a metal. Methane might break down into carbon and hydrogen, with the carbon forming diamonds that rain down toward the planet's core. These exotic states of matter have properties we're only beginning to understand. They might explain some puzzling features of Uranus and Neptune, like their unusual magnetic fields. Understanding the interiors of ice giants also helps us understand exoplanets. Many of the exoplanets we've discovered are similar in size to Uranus and Neptune, and knowing what conditions exist inside these planets helps us interpret observations of distant worlds. Mystery number 90 involves the great dimming of Betelgeuse that we mentioned earlier, but there's an additional mystery. After Betelgeuse returned to normal brightness, astronomers noticed something strange. The star's surface appears to have changed. Before the dimming, astronomers had mapped Betelgeuse's surface using advanced techniques that can resolve features on the star, even though it's hundreds of light years away. They saw bright spots and dark regions, evidence of the giant convection cells moving hot gas around. After the dimming event, the pattern of bright and dark regions was different. The star's surface had been rearranged. This suggests that the dimming wasn't just caused by dust blocking our view. Something happened on the star itself, some massive upheaval that changed the surface. One possibility is that a huge mass of material was ejected from the star, carrying away magnetic fields and rearranging the convection pattern. Stars like Betelgeuse are unstable, pulsating and throwing off material as they approach the end of their lives. The dimming event might have been a particularly dramatic example of this instability. Watching Betelgeuse over the coming years will tell us whether the surface continues to change and whether another dimming event occurs. Betelgeuse is a nearby star in the final stages of its life, and every change we observe teaches us about stellar evolution and the processes that lead to supernova explosions. Mystery number 91 is about the density of Saturn. Saturn is the least dense planet in the solar system. Its average density is less than water, which means that if you could find a bathtub big enough, Saturn would float. This is because Saturn is made mostly of hydrogen and helium, the lightest elements, with only a small rocky and icy core at the center. But here's the mystery. Saturn gives off more heat than it receives from the Sun, about twice as much. This means there's an internal heat source. Jupiter does the same thing, and for Jupiter, scientists think the heat comes from the planet slowly contracting under its own gravity, converting gravitational potential energy into heat. But Saturn is smaller than Jupiter and should have cooled more, so this explanation doesn't fully work. Another idea is that helium is separating from hydrogen inside Saturn and sinking toward the core, releasing heat as it falls. This process, called helium rain, would explain the excess heat, and it would also explain why Saturn's atmosphere has less helium than expected. The helium is raining down into the interior, but we can't see inside Saturn to confirm this. We have to infer what's happening from the heat we measure and from models of how gases behave under extreme pressure. Understanding Saturn's interior helps us understand gas giant planets in general, including the many Jupiter-like exoplanets we've discovered around other stars. Mystery number 92 involves the solar system's obliquity, the tilt of the planet's axis. Earth is tilted at about 23.5 degrees, which gives us our seasons. Mars is tilted at about 25 degrees, similar to Earth, but the tilt of a planet's axis can change over time due to gravitational interactions with other planets and with the Sun. Earth's tilt is relatively stable because the Moon's gravity helps to stabilize it. Without the Moon, Earth's tilt would vary much more, swinging from nearly 0 to more than 80 degrees over millions of years. This would cause wild climate changes, with the poles sometimes pointing almost directly at the Sun, and sometimes getting no sunlight at all. Mars doesn't have a large moon to stabilize it, and scientists think its tilt has varied considerably over its history. This might explain some of the geological features on Mars, like the polar ice caps and ancient riverbeds, which suggest Mars's climate has changed dramatically. The mystery is understanding exactly how planetary tilts evolve and what effects these changes have on climate and habitability. For exoplanets, knowing whether they have stabilizing moons could be important for determining whether they could support life. A planet with a wildly varying tilt might have such extreme climate swings that life couldn't survive. Earth's stable tilt, maintained by the Moon, might be one of the factors that has allowed complex life to evolve here. Mystery number 93 is about the nature of time. This might seem more philosophical than scientific, but it's actually a deep mystery in physics. Time seems to flow in one direction, from past to future. We remember the past but not the future. Eggs break but don't spontaneously reassemble. The universe seems to have an arrow of time, but the fundamental laws of physics, from Newton's laws to Einstein's relativity to quantum mechanics, are time symmetric. They work just as well if you run time backward. If you filmed a collision between two particles and played the film backward, it would still obey the laws of physics. So where does the arrow of time come from? Why do we experience time as flowing in one direction? The answer seems to be related to entropy, the measure of disorder. The second law of thermodynamics says that entropy always increases in a closed system. The universe started in a very low entropy state, very ordered, right after the Big Bang. Since then, entropy has been increasing, disorder has been spreading, and this gives time its direction. The past is the direction of lower entropy, the future is the direction of higher entropy. But this raises another mystery. Why did the universe start with such low entropy? Why was the Big Bang so ordered? A random initial state would have been high entropy, disordered, and time wouldn't have a clear direction. The fact that the universe started in a special low entropy state is a deep puzzle. Some cosmologists think it's related to the physics of the Big Bang itself, or to what came before the Big Bang if there was a before. Understanding time's arrow is one of the fundamental questions in physics, connecting thermodynamics, cosmology, and the nature of reality itself. Mystery number 94 involves the search for Planet 9. We've mentioned Planet 9 a few times, but the search itself is a mystery worth exploring. If Planet 9 exists, why haven't we found it yet? The problem is that it's very far away, very faint, and moving very slowly. At the distances where Planet 9 is predicted to orbit, it would take 10 to 20,000 years to complete one orbit around the Sun. This means it moves very slowly against the background stars, making it hard to spot. It would also be very dim, reflecting very little sunlight. Astronomers are searching for it by taking pictures of large sections of the sky repeatedly and looking for objects that move slightly between images. This is painstaking work because there are millions of background stars and galaxies to sift through. Some astronomers are using computer algorithms to help identify candidates, while others are manually searching through data. There have been a few false alarms, objects that looked promising but turned out to be something else. The search continues, and new telescopes coming online in the next few years, like the Vera Rubin Observatory, will scan the sky more thoroughly and might finally find Planet 9 if it's out there. Or they might rule out its existence, which would also be important because it would mean we need a different explanation for the strange orbits of distant Kuiper Belt objects. Either way, the mystery will be resolved. Mystery number 95 is about the magnetic field of Mars and its ancient history. Today, Mars has no global magnetic field, only small patches of magnetized rock in the crust, relics of an ancient magnetic field that shut down billions of years ago. We know Mars had a global magnetic field because these patches of magnetized rock preserve the direction of that ancient field, like a fossil record. The mystery is what happened. Why did Mars's magnetic field turn off? The leading theory is that Mars's core cooled and solidified. Magnetic fields are generated by the motion of liquid metal in a planet's core, and when the core solidifies, the motion stops and the field disappears. But why did Mars cool faster than Earth? Mars is smaller, so it has less internal heat and a larger surface area relative to its volume, allowing heat to escape more quickly. Once the magnetic field shut down, Mars became vulnerable to the solar wind, which stripped away much of its atmosphere over billions of years. This changed Mars's climate from warm and wet to cold and dry. Understanding what happened to Mars's magnetic field helps us understand planetary evolution and the conditions necessary for maintaining a habitable environment. It also has implications for exoplanets. Rocky planets around other stars might lose their magnetic fields as they cool, and this would affect their ability to retain atmospheres and support life. Mystery number 96 involves the lithopanspermia hypothesis, the idea that life might spread between planets on rocks. When a large asteroid hits a planet, it can blast rocks into space with enough speed to escape the planet's gravity. Some of these rocks can travel through space and eventually land on other planets. We know this happens because we found meteorites on Earth that came from Mars and from the Moon. The mystery is whether life could survive such a journey. Being blasted into space would subject microorganisms to enormous forces, extreme temperatures, and intense radiation. Then they would spend potentially millions of years in the vacuum of space, exposed to cosmic rays and ultraviolet light, before crashing onto another planet, which would subject them to another round of extreme heating and impact forces. Could any organism survive all of that? Some experiments suggest it's possible. Scientists have exposed bacteria to space conditions on the outside of the International Space Station, and some survived. Bacteria can form spores, tough protective shells that are incredibly resilient. If they're buried inside a rock, they would be shielded from radiation. When the rock enters a planet's atmosphere, the inside stays relatively cool even as the outside burns up. So it's conceivable that life could spread between planets this way. If this has happened, it means life on Earth might have originated on Mars, or life on Mars might have come from Earth. We might all be Martians, in a sense. Resolving this mystery requires finding life elsewhere in the solar system and comparing its biochemistry to Earth's to see if there's a family relationship. Mystery number 97 is about the Fermi paradox. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial civilizations existing and the lack of evidence for or contact with such civilizations. The universe is vast, containing hundreds of billions of galaxies, each with hundreds of billions of stars. Many of these stars have planets, and a significant fraction of those planets might be habitable. Even if the probability of life arising on any given planet is very low, the sheer number of planets suggests there should be many places where life exists, and at least some of those should have developed intelligent civilizations capable of technology and space travel. Some of these civilizations might be millions or billions of years older than us, giving them plenty of time to spread across the galaxy. So, where is everybody? Why haven't we detected any signals from alien civilizations? Why haven't they visited Earth? This is the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" There are many proposed solutions. Maybe intelligent life is extremely rare. Maybe civilizations tend to destroy themselves before they become spacefaring. Maybe space travel is much harder than we think, and civilizations stay confined to their home systems. Maybe they're out there but deliberately avoiding contact with us. Or maybe we're looking in the wrong way or listening at the wrong frequencies. The Fermi paradox is one of the most profound mysteries we face. It touches on questions about the nature of life, intelligence, technology, and our place in the cosmos. Every new exoplanet discovery, every advance in the search for extraterrestrial intelligence brings us closer to an answer, but the silence continues. Mystery number 98 involves quantum entanglement and what it tells us about the nature of reality. Quantum entanglement is a phenomenon where two particles become connected in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. Einstein called this spooky action at a distance and thought it showed that quantum mechanics was incomplete. But experiments have confirmed that entanglement is real. If you have two entangled particles and you measure one, the other's state is determined instantaneously, even if it's on the other side of the universe. This doesn't allow faster than light communication because the results of the measurements are random, but it does show that the universe is fundamentally non-local. The particles are connected in a way that transcends space. The mystery is what this means about the nature of reality. Are the particles truly affecting each other across vast distances, or is there some hidden connection we don't understand? Does quantum mechanics describe reality as it truly is, or is it just a tool for making predictions? Some interpretations of quantum mechanics say that entangled particles are part of a single quantum system that can't be broken into separate parts. Others invoke parallel universes or retrocausality, effects that work backward in time. None of these explanations is entirely satisfying, and the debate continues. Quantum entanglement is not just an abstract puzzle. It's being used in developing quantum computers and quantum communication systems. Understanding it better might lead to new technologies and new insights into the fundamental nature of the universe. Mystery number 99 is about the end of the universe. Cosmology tells us not just about the universe's past, but also about its future. Based on current observations, the universe will continue expanding forever, driven by dark energy. As it expands, galaxies will move farther and farther apart. Eventually, billions of years from now, galaxies outside our local group will be so far away that their light will no longer reach us. The night sky will become emptier. Stars will continue to form for a while, but eventually the gas needed to make new stars will run out. Existing stars will burn out, and the universe will grow darker. Trillions of years from now, even black holes will evaporate through a process called Hawking radiation, leaving behind only a faint haze of particles and radiation. The universe will approach a state of maximum entropy, a heat death where nothing interesting can happen anymore. But this prediction is based on our current understanding of physics, which might be incomplete. Maybe dark energy will change, causing the universe to contract in a big crunch. Maybe vacuum decay will occur, a phase transition that changes the laws of physics and destroys everything. Maybe there are cycles, with universes being born and dying in an eternal sequence. The far future of the universe is one of the deepest mysteries in cosmology, and it's intimately connected to questions about dark energy, the nature of time, and the ultimate laws of physics. Mystery number 100 brings us full circle to the cosmic microwave background radiation and what it can tell us about the very first moments of the universe. The cosmic microwave background is a snapshot of the universe when it was only 380,000 years old, the moment when it became transparent to light for the first time. But scientists want to probe even earlier, to the first trillionth of a second after the Big Bang. At that time, the universe was so hot and dense that even light couldn't travel freely. We can't see that era with light, but we might be able to detect it through gravitational waves. The theory of cosmic inflation, which we've mentioned, predicts that the rapid expansion in the first fraction of a second after the Big Bang would have created gravitational waves, ripples in space-time that would have left a faint imprint on the cosmic microwave background. Astronomers have been searching for this signal, looking for a specific pattern of polarization in the microwave background radiation. In 2014, a team announced they had detected it, but later analysis showed the signal was actually from dust in our own galaxy. The search continues with more sensitive instruments. Finding this primordial gravitational wave signal would confirm inflation and give us a window into the universe's first moments, a time when the laws of physics were being tested under the most extreme conditions possible. It would answer questions about how the universe began, what caused the Big Bang, and what the fundamental nature of reality is. This is the ultimate mystery, the origin of everything, and we're closer than ever to finding answers. We've journeyed through 100 mysteries that NASA and scientists around the world are still working to solve. From the depths of black holes to the edges of the universe, from the smallest particles to the largest structures in the cosmos, we've explored questions that challenge our understanding and push the boundaries of human knowledge. Some of these mysteries might be solved in your lifetime. New telescopes, new spacecraft, new experiments, and new theories are constantly advancing our understanding. What seems mysterious today might be common knowledge tomorrow, but new discoveries always bring new questions. Science is not about finding all the answers and stopping. It's about asking better questions, probing deeper, and marveling at the complexity and beauty of the universe we inhabit. As you drift off to sleep tonight, let these mysteries fill your dreams. Imagine yourself floating through space, past planets and stars and galaxies, witnessing the wonders we've talked about. The universe is vast, ancient, and full of secrets waiting to be discovered, and you are part of it all, made of star stuff, asking questions about where you came from and what it all means. Sleep well, cosmic explorer. The mysteries will still be here tomorrow, waiting for curious minds to unravel them.